Great. Hello and welcome everybody to this Saturday event called Weather Live, and we'll be looking at weather extremes that have happened around the world in the last year or so. Lots of extremes to talk about, and we'll take a focus in on some of those extremes and have a look at how we warn for extremes. And I think it wouldn't be an event running in 2021 if we didn't have a focus on COP26 as well. So we'll have a presentation on that. So I'm Professor Liz Bentley. I'm Chief Executive at the Royal Meteorological Society, and I'm delighted to welcome you all here today. I can see many of you saying hello in the chat and letting us know where you are, where you're joining us from today, and some weather updates as well from where you are as well. So please feel free to join in the chat and let us know where you're joining us from today. This event is run in association with AccuWeather, who are the sponsors of Weather Photographer of the Year, and we'll be announcing the winners of the Weather Photographer of the Year 2021 later on in this event as well. But without further ado, I'm just going to run through some administration. The first thing really just to do a little bit of a plug for the Royal Meteorological Society membership. So if you're not already a member of the Royal Meteorological Society, can I encourage you to think about joining? There's a multitude of different benefits from being a member of the Royal Meteorological Society, and you can see those listed here. And at the bottom of this slide, there's a website link if you want to find out more, or an email address if you wanted to ask a few questions about becoming a member of the Royal Meteorological Society. You'd probably also be interested in Met Matters. So we launched Met Matters earlier this year. It's a replacement for what used to be the Weather Club, for those of you who are involved with the Weather Club for a number of years. Met Matters is our public engagement arm. So we provide lots of information about weather and climate, about events around the topic, lots of facts and information. In fact, one of our recent guest writers for Met Matters is a speaker today as well. So I'll introduce her later. So yeah, the web link at the bottom of the page, if you haven't explored the pages of Met Matters, I would encourage you to do so. For those of you who are new to Demio, the platform that we're using today, if you have any problems, either with audio or anything visual, can I recommend that you exit the event and then make sure that you're using one of the recommended browsers that you can see here on the slide, and then rejoin, and hopefully that will resolve any issues. But if you've got any problems, please just put them in the chat, and my colleagues who are on this call with us will hopefully resolve that for you. If you want to make the screen a little bit bigger so you can see the slides a bit better, then you can close the chat function. So there's the top of your screen, you'll see some little icons. There's a vertical line with an arrow pointing to the right. If you click that, that will shut the chat up and will make the screen a little bit bigger so you can see the slides. There's also two diagonal arrows. Again, if you click that, it'll make the slide full screen. So there's just some different options to increase the size of the PowerPoint slides for viewing the presentations. And I would encourage you to put any questions that you have for the speakers in the chat. Do that during their presentation, and I'll try and get to as many of those questions as I can during the question and answer session at the end of each of the presentations that you're going to see today. So here's the programme, and in a few minutes I'll be introducing our first speaker. The first part of the Weather Live will focus on weather extremes. We'll get an overview of the extremes that have been happening around the world in the last year or so, and then we'll home in on extremes around flooding, around heat waves, and around wildfires. And then after the break, we're going to take a look at how we warn for extreme events in the UK. We're joined by Will Lang from the Met Office. And then David Warriller, who is past president of the Royal Meteorological Society, will take us on an overview of COP and particular focus with COP26 that's coming in a couple of weeks' time. And then we'll get to our finale event, which is announcing the Weather Photographer of the Year winners, which we'll do at the end of this event. So I'm going to invite our first speaker to the stage, and I'm delighted today that we've got Dr. Chris White, who is head of the Centre for Water, Environment, Sustainability and Public Health at the University of Strathclyde. And this centre undertakes fundamental and applied research that provides novel solutions to some of the most pressing global environmental challenges, including net zero and the circular economy, water and waste, environmental health, and climate resilience. And Chris is going to take us through some of the many extreme weather events that we've seen both here in the UK, but also globally over the recent months. So over to you, Chris. So I can't hear you, Chris. I don't know if you can unmute. Yes, I can hear you now.
Okay,
perfect. So we can see your slides and hear you.
Okay, sorry, probably didn't have that plugged in quite right. Okay, slightly full start, but thanks very much, Professor Benny. Thank you for the introduction. So as was indicated there, I'm University of Strathclyde in Glasgow. I'll do a quick intro to myself and the centre just before we get started. But as Professor Benny there indicated, I'm going to talk a little bit about recent events. Going to focus primarily on 2020 because that's a whole year, so we can get some statistics from that year. And I lean quite heavily on the recently published State of the UK Climate report, which covered the year of 2020. And then there's a little bit in there around, of course, some of the more recent events that we've seen in the last, over the last summer in particular. But I'll focus on UK and a little bit of international as I go through. So a very quick introduction. Professor Ben did a perfectly good job. She's very clearly indicated that University of Strathclyde, I head the centre here, Centre for Water, Environment, Sustainability and Public Health. In particular, my interests and my, I suppose, research interests are in very much the extreme events, the understanding the dynamics and the causes of the events, their prediction. But perhaps given, I mean, an engineering department, it's the climate resilience side. So it's the building resilience and adapting to our changing climate and weather extremes. So I'm very applied, I suppose, in my area of research and interest. But part of that very much covers understanding the extremes themselves. And like a lot of us, I'm sure on in this session here, we all take a very keen, we'll pay keen attention to what goes on and the different events that are occurring and perhaps their frequency and extent as they occur. So that's myself. So I'm here in Glasgow, and I'm interested to listen to the talk a little bit later on, in particular about COP26, which of course is going to be happening just about 2 miles in that direction in a few weeks' time. So let's focus on the main part of my talk here this afternoon. Which is around UK and global extreme events. And it's a bit of a look back over probably the last year and a half or so on some of the record-breaking and noteworthy extreme events, with a particular focus, like I said, on the UK, but there's a little bit in there about some of the more international events that have occurred. I'll just start, though, first with, as I said at the outset, we're going to focus on use, I suppose, quite a bit the State of the UK Climate 2020 report, the RMS report that's published in the International Journal of Climatology. As this gets published, of course, published every year. But it's a great place to start because it puts the context of the year as a whole. And before we start, then perhaps looking at a little bit of some of these events individually. And of course, 2020, as I'm sure many of us know, had either broke certain records or certainly nudged a few of the records throughout that course and throughout the course of the year. And I think some of the statistics, some of the numbers that came from 2020 where the sort of generalized kind of statements of temperature, rainfall, length of sunshine for 2020 being in the top 10 on record. And I'll touch on this point a little bit again a little bit later on in the talk. But crucially, 2020, like many of the years before it, and indeed probably the way that 2021 is tracking as well, is we're living in a climate that is increasingly warming, and the extremes that we're starting to see are either increasing perhaps in frequency or magnitude or spatial extent. And again, I'll perhaps try and pull on a couple of those examples as I go through here. But quite a lot of information on this slide. This is straight out of the State of the Climate report for 2020. But the underlying climate signal is very much within there, and also I'll come back to that as we go. But I think one of the overriding pictures for me from 2020 was a couple of the kind of standout events when it came to exceptional rainfall. In particular, that's sort of second down graphic there, where is the fifth wettest year on record. But most importantly, it was the wettest February on record, and that was February 2020. And that was born largely from 2 storms that happened in very quick succession. Because this is the time of year where we would expect, of course, to see winter storms coming off the Atlantic, and this was a period that perhaps is not so uncommon. I think what was particularly striking about these 2 events, so Storm Ciara and Storm Dennis, that happened, like I said, a week apart from each other in February 2020, was just their quick succession. Now, extreme events have always happened, will always continue to happen, but they do happen relatively rarely. By definition, they are extremes, they are rare events. But it was that quick succession coming from quite a wide extent event, Storm Ciara, which was in 8th, 9th or so of February, and then closely followed up by this other storm event of Storm Dennis a week later, that put such pressure on our systems and of course put an awful lot of rainfall on what was already quite saturated ground. And I know, coming from an engineering background, that it's those sorts of problems that are often perhaps the most difficult to deal with, because you're preloading the event, or the likelihood of a high impact is much greater, because they've already had that weighting, that loading that's happened from the event before. Now, although Storm Dennis in particular had some significant impacts on the UK, in particular South Wales, I think, bore the majority of the brunt, not exclusively, but the brunt of the weather event that we saw, and there was some quite significant flooding in many regions. We saw some exceptional rainfall totals, nearly 160 millimeters in some locations, which meant that they were getting monthly average totals within a very short space of time. Is that, of course, high intensity, very quick duration rainfall that is a challenge, of course, to predict and to forecast. And again, I'm looking forward to seeing a couple of the presentations shortly after this around the prediction and warnings for events. But also then, of course, it's just that quantity of water that is going to lead to flooding somewhere, and it's then, of course, how do we deal with the aftermath of that. But here in the UK, we were, yes, we were impacted, and not insignificantly, but it was mainland Europe that perhaps had a much higher impact, because it was quite significant flooding, flash flooding, washed away roads and what have you within mainland Europe. It kind of skirted us to some degree. We definitely got an impact, but it's skirted sort of across the bottom of us a little bit. But again, it's that quick succession of these 2 events that I think was quite noteworthy and standout for this period of time. If we then skip forward into October, whilst we're on the topic here of storms, Storm Alex, which kind of happened over a few days, sort of 1st, 2nd, 3rd or so of October, again was a sequencing, a series of rain events caused by a very low pressure system, culminating in some very high rainfall totals, in particular on the 3rd of October, which meant that we had an average of rainfall of 30 millimeters. That's across the UK. That's an awful lot of water, and it is interesting that even in the State of the Climate UK report, the quote that was used in the press at the time was enough water to fill Loch Ness. And anyone, well, I'm in Scotland, I know Loch Ness fairly well. It's a big loch, and that's a lot of water to fill. So I'm not quite sure of the accuracy of that as a statement, 7.6 cubic kilometers of water. but someone's obviously done a bit of a back of an envelope calculation and come up with that as a statistic. But as a standout event, again, an exceptionally wet period and wet event. And what those events and others, of course, I'm just picking on a couple of the kind of standout storms really from 2020. What that means is we then get a very mixed picture in terms of what we would class as seasonality. So how much rainfall we have in any one given season. And it meant then that we had a very wet winter, in particular driven by that very wet February, those two events in February. But then that was closely followed by a pretty dry spring. And from a management perspective, water management, water resource perspective, that mix of extremes, so some very extreme rainfall, then closely followed by quite a dry period, or drier than average period, means that's a real challenge, because it means then the water's perhaps arriving maybe at a different time than we might be used to, or just in quantities in perhaps ways that may not have always been the case. So again, from an engineering or from a resource perspective, that's quite significant. Now, it's inescapable if you watch the news or keep up with anything that's going on with the weather. Of course, temperature is perhaps for me, at least in the last year and a half, has been one of the real highlights or most noteworthy points that have been made. That, of course, our increasing temperatures are very much driving an increase of high temperatures that we're seeing and heat waves. And 2020 was no exception. We recorded the third highest daily maximum temperature in the UK. It was 37.8 degrees at Heathrow at the end of July in 2020. That was quite a widespread heat event, but relatively short, that one. But that was then closely followed by August 2020, so between roughly the 7th and the 12th of August, with some very high temperatures, and most importantly, some very high nighttime temperatures retained within that period as well, which means some very uncomfortable nights. And of course, from a human health perspective, it's heat waves that are really starting to cause some issues and some real problems. And to take those events, and that's just some of them in the UK within that sort of 2020 period. If you take a little bit more of a global perspective, well, 2020 was a record in terms of billion-dollar disasters. I mean, perhaps a bit of an American perspective. It's in US dollars. But even when adjusted for inflation, it means there are more events in 2020 that passed that threshold. 22 of those 50 that were actually within the US in particular. So it was a noteworthy, a standout year, I suppose, for records and record breaking globally, even if in the UK we had some significant events, but perhaps not quite up to that world ranking, let's say, or billion-dollar type of disasters. But the US in particular saw some quite significant events throughout 2020. Some of those would have been driven by an awful lot of activity in the Atlantic from hurricanes. We saw 30 named storms during the 2020 Atlantic hurricane season, which is the highest on record, including Hurricane Eta, which was I suppose the most dangerous, the most deadly of those events, with nearly 300 people being killed in 2020. So it was a significant year for hurricanes, and again, that very much contributed to some of those billion-dollar disasters that we saw within the US. But of course, that's just one part of the world. Looking a bit more globally, China, as indeed it has this year again, but China experienced some very, very significant flooding. It's hard in many ways to say what's the worst impact. Is it the cost? Is it human life? Of course, human life is the most important here. The metric that was used is damage and dollars worth of damage. In this case, $32 billion worth of damage from the monsoonal floods that happened June to September in 2020. So a high death toll, but also very much a high cost associated with this event. And again, to bring it back to the temperature temperature question or issue, I suppose, it's been inescapable, like I said, that temperature extremes are very much part of the picture of where we are now. We've seen in year on year now quite significant, very significant temperatures and wildfires in the Arctic, subarctic, and up into the Arctic. This is, of course, places where traditionally fires are not so much of an issue now, increasingly becoming an issue with climate change as the large driver. And if you think right back to the beginning of 2020, so actually at the end of 2019 and into 2020, Australia had one of its worst bushfire seasons on record, with very, very significant fires. And to bring that back to the human health impact, the smoke from these fires meant large parts of Australia, so not just now within where the fires directly are, but a lot of areas of Australia, the people there, of course, are breathing very poor quality air for quite a significant period of time. So the fires have a very direct impact, but also there's that human health component, not just from the heat, but very much from the smoke as well. And it'd be remiss of me to not really point a little bit to 2021. So the focus really of my talk, or this short presentation, is 2020. But of course, we've seen the same pattern of events, let's say, with record-breaking events that have then continued very much through this summer. It'd be interesting to hear, I suppose, the equivalent of this kind of talk in perhaps a year's time, because we only have to look to Canada, the US, where we've seen incredible record-breaking events of drought, heat, and fire, and those combinations between those over very wide areas. And of course, we've seen in Western Europe the major floods in Germany, Belgium, and neighbouring countries that happened throughout the summer. Very deadly events occurring there, as well as some more localized events, flash flooding. We've seen in London a couple of times, New York with flooded subways and underground systems. But that's 2021, so I'm focusing here really on 2020. Now, it'd be remiss of me really, though, as well, to then not really look at just a little bit of the background as to perhaps some of the changes as to why, of course, we're seeing some of these events occurring, or what might be contributing to them. I'm sure in one way or another we've seen climate projections, so we know roughly where we are. We're at roughly a degree or so of warming from pre-industrial times, and our climate models are projecting multiple realizations or plausible futures based on different scenarios. Of course, trying to limit that increase to 2 degrees, but the models will of course produce outputs in which we can look at multiple pathways as to which we might be heading down, whether that's 2, 3, 4 degrees of warming into the future. And to put that in the context here in the UK as to perhaps what we've seen up to now, we've seen that warming trend going through the decades, and figures like this, of course, are really informative, where you can look at the fact that 5 of our warmest years have been in the last decade or a half or so. Can contrast that against some of our coolest years, which are some of those are well over a century ago now. So that there's variability, of course, in here. It changes from year to year, but that clear warming trend visually represented here very nicely, very neatly for us. So a quick look to what does this mean for the future, and you can contrast that against some of the events we've seen this summer. I think, again, perhaps the highlight or the most noteworthy here is, of course, our future temperatures. Those increases, again, depending on what we do with our CO2 emissions and getting towards net zero. Again, when we think about COP26, again, which is going to be happening here in a few weeks' time, this is the point where we very much need to spend our time and effort in reducing these down. That, of course, those higher temperatures increase flood risk, because higher temperatures mean there's more moisture in the atmosphere, higher likelihood of flood risk, and the impact to people, the number of people that are likely to be impacted from flooding, is only going to increase. But again, depending on which pathway, which route we end up going down, based on how much we start to decarbonize our environments and our systems. And then you can make that direct correlation with temperature and increased drought likelihood means we're setting the scene for increase of wildfires. We've seen fires already. There were fires in February this year, so middle of winter in the Scottish Islands, for example. We're only going to see those the likelihood of those increasing. And just that final piece on the complex and the interactions between these hazards, we're really just starting to understand that a lot of these events, of course, don't occur singly. They co-occur, or one will contribute to another. Again, perhaps take the most recent event in Canada and the US, where a long-term drought sets the scene for when we have high temperatures. It's the perfect recipe, let's say, for wildfires. And those complex interactions, cascading risks, and the knock-on effects to things like our supply chains and our human health systems are very much all intertwined with each other. And I'll just end here on this last piece. This was from the Environment Agency, and I know I think Joe's going to be speaking next from the Environment Agency. That this was a report which came out just a couple of days or so ago that very much talks to the fact that we, of course, need to live with climate change. We are living with climate change already. That's not going to change. What we do need to be doing is, I think, more effort, more time and effort into our building resilience and adapting to climate change. And I think the key words in here is adapt or die, which is very, very alarming words, but then we only have to look at the IPCC report, which came out last month. It's similar, strongly worded reporting, and it pulls no punches, I think is the word. So I'll leave it there as just a quick look really on 2020. Record-breaking events. We've seen, of course, those already spreading into 2021 as well. And there's that backdrop of climate change that's in changing the risk, changing the frequency, the seasonality, how our rainfall arrives and how our temperatures arrive in the last of the last year or so. It's a lot packed in there to a very short space of time, but hopefully not overrun too much, and I'll stop right there. Thank you very much, and thanks very much for listening.
Brilliant. Thank you very much, Chris. Great way to start our Weather Live session. Really interesting. And as you say, lots to talk about, lots of weather extremes, even in just this last kind of 12, 18 months. Great summary. Great to get us started with that. So thank you very much. I've got a quick question, really. You finished talking about the Environment Agency report, and, you know, it's about how we keep the communication going around this. And, you know, we get all these extreme events, and, you know, you can almost become a little bit complacent in the sense, oh, it's another record breaking. And some of the examples you used, you know, the extreme rainfall that we had in October last year, and, you know, the kind of analogy or the similarity with the amount of rain filling Loch Ness. Do we need to keep finding ways of trying to kind of emphasize that these are, you know, really extreme, exceptional events?
Yes, I think it's the answer. I don't think it's a message that needs to keep on being said. And I think we all need to find ways to communicate that better. I find, giving presentations like this, you can't help, it sounds like a doom and gloom message, and in some ways there often isn't any other way of doing so, yet it has to be repeated. We have to be recording this information, we have to be giving this sort of data out. And I suppose in a way it's quite reassuring that even in the time that I've been working in this sector, I've seen 3 IPCC reports, the third one just coming out at the moment, is that change of language has gone from somewhat cautionary to very to the point, and say, that word of it pulls no punches, that Environment Agency report just 3 days ago referred to, adapt or die. This is very strong wording. So I think that's one noticeable change that I've seen. And I think we need to be doing a lot more of that. And I think the focus, and again, we'll be interested to hear when we hear about the talk on COP26 in a minute. A lot of our effort, rightly so, is on mitigations, on decarbonising our environment. But aligned to that, very much in parallel, has to be this resilience building and adaptation. The two are intertwined. We can't be doing one without the other.
Great, thanks, Chris. I'm going to pick one question from the chat. So I've got a question from Mike. So in terms of temperature, and you did have a few slides talking about some of the temperature changes and extremes, are we speaking mainly about maximum or average temperature? And he was saying minimum temperatures in Northampton, however, seem to be 4 or 5 degrees warmer than they were 150 years ago. So I guess, could you just clarify what temperatures, when you're referring in your graphs?
Yes, it's a very good point, and if a lot of what I pulled there was from the State of the UK Climate Report. If you look at that report, or publication, it's 80 pages, and there's a whole depth of information in there, and I've just picked kind of some of the highlights. So yes, we often talk about average values. A couple of the plots that I showed, especially the future ones there, were temperatures, were actually an average maximum temperatures. And the rate of rise of average maximum versus average temperatures is higher than average. So that shift of let's say the distribution, the temperature distribution, is felt more keenly in the extremes. So that comment there, that's to a specific place, I can well imagine that temperatures are shifting that much higher at the extreme end of the scale than perhaps at the average end of the scale. And I think that's very much matched with what's in the climate models.
Yeah, and this emphasis, I think, as well, that we're not just seeing it in maximum, but also overnight temperatures. And this term tropical nights, which I think the State of the UK Climate refers to, is being used more and more. I guess we didn't probably refer to tropical nights decades ago. We are now.
That's right. Who would think tropical nights in perhaps the UK climate would be a thing, even in the short term, perhaps in the future, long-term future, yes, but we're talking about it now. That August heat wave in the UK, if I remember rightly, I think there were 4 or 5 nights in a row where the temperature didn't drop below 20 degrees, which is, I suppose, the definition of a tropical night. That makes for some very sticky, very uncomfortable nights. And if from a physiological perspective, from a health perspective, that can have some very significant effects, because the human body's unable to cool before the heat of the day happens again. And that build-up of heat stress within the body is what's the issue there.
Great. So a big thank you, Chris. Lots of rounds of applause kind of coming in the chat. There's a couple of questions in there as well, and I'm just wondering if you're happy to just answer them in the chat as we move on to the next speaker. That'd be great. So thank you very much, Chris. I'm going to move on to our second speaker for this session, and I'm delighted to bring to the stage. We've got Jo Coles joining us next, who is a national flood forecasting manager at the Environment Agency. So Jo is a chartered scientist. She's also a fellow of the Royal Meteorological Society. She's got a background in meteorology, in operational flood forecasting, and in flood incident management. She currently works at the Environment Agency in their evidence and risk department, and she leads a national team of highly skilled flood modelers and forecasters. She also works operationally as well, as part of the National Flood Forecasting Bench. And I mentioned, I think in my introduction, she's written a fact file which we've recently uploaded to Met Matters, and I'll try and put the link in the chat for those who want to read more. So giving us an update in flood forecasting, and I would recommend that as a definite recommended read. So I'm going to hand over to Jo for your presentation on flood forecasting, warning and informing in a changing climate. Hi, Jo. I can't hear you and I can't see your camera at the moment, so I don't know if you can switch both on. Hi, Jo. Okay, I think Jo's leaving, and hopefully we'll try and get Jo to rejoin in a minute. If not, I'm probably going to move on to our next speaker. I'll just give it a few seconds, see if I can get Jo back in connected so we can move on with her presentation. Okay, I wonder if we could then, if we move on to our third speaker, I'll come back to Joe, obviously, so I'll just swap the next two talks around. So I'm going to invite our third speaker to come up first, and delighted to welcome back Tyler Royce. So Tyler spoke at Weather Live last year, for those of you who attended. And Tyler is a senior meteorologist at AccuWeather. He's been working in meteorology for nearly a decade, starting his career in AccuWeather the week before Hurricane Sandy struck the US. So I guess like many of us in meteorology, we often have a weather event that is one of those reasons either why we became meteorologists or when we joined and started our career. Tyler's going to focus on heat waves, and as the title of his presentation suggests, this is a silent killer and an extreme event that actually can have a really negative consequence on many people. So I'm going to hand over to Tyler. Thank you.
Thank you, Professor Bentley, and hello and good afternoon to many of you, or good morning if you're in the States. Silent killer heat waves. I would make the argument that they happen to be the number one weather phenomenon that causes death, and it may not be the leading cause, but it's necessarily the underlying cause. And we'll go through that in this presentation as we define heat waves, and then we go take a look at heat waves that occurred mainly across Europe over the years. And so communications of heat waves are very important. And that's what AccuWeather has been doing for the last 6 decades, has been communicating the weather to not just the public, but businesses, so that they can make the best decisions for their business lines, so that people are safe, but also their own property and business lines are protected. And so that, as I said, we've been doing this for next year 60 years. I mean, we have numerous locations scattered throughout the world in which we have people located in. So AccuWeather and many people are in the communication business of projecting the forecast out there, but how do we define heat waves? How can I put out a forecast that says, yes, there's going to be a heat wave? Well, there's numerous definitions out there. And so the global one is from the World Meteorological Organization, which is you have at least five consecutive days of which the maximum temperature has to be at least 5 degrees Celsius above normal. So if your normal, your average maximum temperature is 25 Celsius, and if you continuously have it at above 30 Celsius for 5 days, according to the WMO, that is a heat wave. But that's not necessarily applied to all across the world. Here in the United States, it varies per region. Where AccuWeather headquarters is in the Northeast United States, the criteria for our heat waves are different than if we were living in the Southwest, where you have Fresno and you have Phoenix. So it depends on largely your location here in the United States. You go over to Netherlands, Belgium, Luxembourg. The criteria is largely you have to have 5 consecutive days of which the temperature has to exceed 25 Celsius. Of those 5, at least 5 days, 3 of them have to exceed 30 Celsius. So you're talking a little more stringent criteria for a heat wave. In Denmark, you add a whole nother criteria of percentage of the country has to meet a criteria in regards to that. So in that case, it's 50% of the country has to be over 28 Celsius for 3 consecutive days. In Sweden, it's a more basic one of 5 consecutive days over 25 Celsius. And in Greece, it's a combination of the maximum temperature and the minimum temperature having to be over a certain criteria. So for the daytime, it has to be over 39 Celsius, and at nighttime, it has to be over 26 Celsius for 3 consecutive days. In the UK, it has to meet the criteria for over at least 3 days. So for North England, Scotland, Wales, Northern Ireland, criteria is about 25 Celsius. You move to the London metro area, it's up to 28 Celsius. So you have to meet those for at least 3 days to meet Met Office's criteria for a heat wave. So once we have this criteria, how do we project? How do we communicate? Hey, yes, we have extreme heat coming. Here in the United States, we have various warnings and alerts. The low, if you want to call it the lowest one, it's a heat advisory, and it ranges all the way up to excessive heat warning. This is taken from earlier this summer with the extreme heat out in the Pacific Northwest. All these warnings here are based on the heat index, which I'll define in a couple of slides. But the heat advisory is essentially falls between the heat index of 41 Celsius to 46 Celsius for less than 3 hours, or your overnight temperature has to be over 27 Celsius for 2 consecutive days. Your excessive heat watch combines that the heat index has to be over 41 Celsius, plus the min temperature has to be over 27 Celsius for 2 consecutive days. And your excessive heat warning is essentially 41 heat index over 41 Celsius for over 3 hours for 2 consecutive days, or any time period of which the heat index is over 46. So there's a lot of minutia criteria for how we issue these warnings here in the United States. So the heat index is largely known as the apparent temperature. And it's when you combine the relative humidity with the air temperature, you put them together, and that's what it's supposed to feel like. It might not even tell the full story, because what if it's windy? What if there's light wind? What if there's cloudy conditions? What if it's totally sunny outside? And that's where the AccuWeather real field temperature comes in, because it takes all other things that are out there, as I just mentioned, puts them into an equation, and you largely get various temperatures, what it actually feels like. So if the air temperature happens to be 32 Celsius, and if you have high humidity and it's windy, your AccuWeather real field temperature might be somewhere around 40 Celsius in the afternoon, and we would classify that as quite hot. And so it goes throughout the temperature scale. To my knowledge, I have yet to see a AccuWeather real field temperature in the extraordinary dangerous heat section. But as we go through, we go all the way onto the opposite extreme as well, with the extreme cold. So this is to help the consumer, to help the public understand that, yeah, it's 32 Celsius outside, but with these other factors, it's sunny, it's windy, the temperature is probably going to feel much different than what the thermometer is reading in that regard. In the UK, and primarily this is geared towards England, the Heat Health Watch has come out, has been in place for several years. It gives an idea of the weather impact the impact from the heat and how people should be preparing. So the level 1 is kind of more like your traditional summer conditions. Your level 2 is essentially there's a risk for temperatures to go above the threshold. And then level 3 is we've had at least one day that's gone over the threshold. Then tomorrow is likely to go over the threshold, so you better be taking action. And then finally, if you have over 3 or 4 days of meeting the criteria, it becomes a national emergency or level 4 criteria in that regard as well. So we take all the various ways that we can communicate it. I wanted just to compare them. So in the bottom left, we have what the heat health alerts out of the UK, what that looks like. And that is very much like in the excessive heat warning that's put out in the United States on the middle right-hand side, which they talk about the synopsis, the criteria for temperatures, and then some precautionary items. The Met Office just earlier this summer has started to actually issue actual warnings that are like thunderstorms, rain, wind, snow. And in this case, it's very much, when you click on them, very much like the other warnings, very impact driven in that case. And then what we do here, just for comparison from AccuWeather standpoint, is on the app or on the website or in radio forecast, television forecast, we're going to supplement that. Yeah, it's going to be 110 Fahrenheit outside, that it's going to absolutely destroy the record that was set back in 2008. We're also going to highlight that, yeah, it's going to be very hot. It's a dangerous heat, and that, yeah, you're going to see whatever warning is out there. So there are numerous ways of how for the public to see and to ingest the same information in this regard. And all of the heat waves, and Chris kind of alluded to in his presentation, have health effects. As I stated kind of in the beginning, is that heat waves, I'm going to make the argument that they are the number one killer of weather phenomena out there. Yes, we have flooding. Yes, we have lightning. But the impact that we're going to see from heat waves in terms of death and the impact it has in an increased amount of deaths is, in my opinion, much higher than flooding or any lightning strikes that do occur. And heat waves largely can trigger heat exhaustion, heat strokes, heat rash. And it's a big reason why some of the impacts that we say is, hey, limit your outdoor activities during the prime heating part of the day. Save it to the early morning. You don't have to mow your lawn at 3 o'clock in the afternoon. Do it early morning and maybe check off your neighborhood. Or you do it in the early evening hours when the sun is starting to go down. Those who are really at high risk happen to be your older adults, very young children, those who are sick and overweight. But also more recently, there's been some literature that's come out that we really haven't talked about, but that's also pregnant women. And that kind of hit me a little bit hard, largely because I've had a friend who happened to have given birth today. She's been pregnant, and we've had some extreme heat. So it made me kind of gave it a little more like, something that we really haven't talked about and that we probably should be talking about. And the last one is it can cause other stressors to your life. So we have the health side effects, but now we also have the structural. And so the big thing that we see when you have these big heat waves is power cuts. You have rolling blackouts. You have brownouts, largely because the energy demand goes up, but maybe the power supply goes down because the power companies, the power plants have to reduce what they output because maybe the rivers that they use to cool their systems, the water temperature is too warm. And we're going to see that in the theme throughout most of these heat waves. That becomes a problem. The power supply has to decrease because the river waters, are too low and they're too warm to help cool the power plant. And what I also call the feedback loop is a lot of these heat waves have a preceding drought or dry period leading to them. So the dry ground, you have the heat that rises, and then you get your heat, several days, you meet your criteria, get your heat wave. Well, that heat dries the ground, and it's a continuous loop. We saw that a large part across the northern plains of the United States this year. And then finally, all these heat waves, what do they do to how we communicate, how we drive? It impacts all of that. It can lead to melting of tarmacs, which we've seen at Heathrow in the past. It leads to railroads buckling. So the picture here, that's why trains will either stop service or go at slower speeds, because if you have a train going 70 miles per hour down the track, they necessarily can't react to if the track buckles, then you get a derailment. So the big thing is transportation effects due to the heat in this regard. So I've been at the Europe desk here at AccuWeather for 5, 6, 7 years. And something I've been tracking during this time is what I call hot days, or days at or above 32 Celsius. So for these select cities, I've gone into the past, typically since 1973, some of them 1950s or 1940s, and I figured out what's the average and the median number of hot days. Then I thought, well, for this presentation, it would be great to use this data. So then I compared it to the last decade, the last 10 years. And for every location, there's been an increase. The more drastic increase has been in Eastern Europe, where Kiev, Warsaw, and Moscow have all seen at least around 250 to 275% increase in the number of hot days on average, which is just, I won't say it's mind-blowing, but it supports what we've been hearing and seeing with the increased number of heat waves going forward. So let us take a dive into some of these heat waves. The baseline heat wave we're going to take a look at is 1540. What caught my attention was a drought that lasts for 11 months. But in reality, this drought started the previous autumn in 1539. And not a lot has been written about it, but from what I was able to find is that the estimations of what the average temperature was during the summer during this time probably exceeds the average temperature during the summer of 2003, which happens to be, if you want to call it, the creme de la creme of heat waves that kind of awoken many people in Europe to, oh, this is a very significant thing, in which we will talk about that one down the road. Led to many fires, which led to hazy sunshine, a loss of sun, and there's estimations, and I would call this, we have to use this roughly, up to 500,000 perished because of that. The next one that is kind of on the list that I wanted to highlight was the British heat wave, or the European heat wave, which happened to be one of the hottest summers. Again, leading up to August when this occurred, so January to August, many locations are only up to 50% of normal rainfall. You saw significant crop losses across the UK. But also very interestingly, there's a boom in ladybugs, which I found to be very interesting. Something I probably would like to look into a little bit more going forward. So those were the two big ones kind of prior to 2003. And I just the graphics going forward were created by a colleague of mine, Mike Dahl. So I'm very appreciative for making these graphics. But 2003 is kind of, as I said, the big one, where eye-popping values, not necessarily maybe in the temperature department, but the impacts. So yes, parts of France saw 8 consecutive days of 40 plus Celsius. The UK saw for the first time 38 or recorded temperature over 38 Celsius. It was the number of deaths that occurred here, which was over 70,000 deaths. And it wasn't all directly due to heat, but indirectly due to heat. And a good portion of them came from France. It led to a great loss in wheat, about 10% of the wheat crop across Europe. And it also allowed the grapes to ripen much earlier than they typically do, which led to a higher alcohol content of 12 to 12.5%, which has made this year's wine probably much more exceptional, is what I was reading, and also much more rare out there. In 2006, so 3 years later, you're talking about the warmest July in record since official measurements began. Significantly low amount of deaths, but the one thing that I found in my research here is there's a lot of underestimations here. We're not necessarily sure that of all the deaths that had a link to heat. So we're kind of an underestimation here of almost 3,500 deaths. The UK Environmental Agency said about this severe drought, most severe drought in 100 years. You had rolling blackouts, significant crop loss, and also one of the most sunniest Julys on record. Funny thing is, once this heat wave ended, it became one of the cloudiest Augusts on record for many locations across Europe. The heat waves of 2007 primarily took place in Southeast Europe in 2 distinct periods. It led to almost a power grid collapse across Greece and across many places in the Balkans. You had 3 to 4 times the yearly average number of fires reported in Bulgaria. So very significant in regards to that. 2010, 2015, big one was mainly in Russia. And this is where we talk about the indirect number of deaths due to heat. And a lot of that came from drownings in Russia. So overall, this heat wave caused the indirect deaths around 16,000. Almost 1,500 of them were due to drowning accidents because people really didn't know how to handle the water. They were in spots that typically people weren't in. And it was also the worst drought in 130 years. In 2015, you had a new record set in Heathrow of 37 Celsius. In 2018 begins what I kind of call the 2018-2019, of which it was Western Europe kind of dealt with prolonged dry periods. I wouldn't necessarily, we could claim that they're droughts, but up until we have had these 2 heat waves, there's about 20% normal rainfall. You saw 20 to 30% lower crops in Germany. And because of the prolonged dry periods, again, the nuclear power plants had to reduce their output because of the low, warmer waters in the rivers. And then 2019 can probably be combined with 2003 in terms of the impacts and the impressiveness of it. Again, the number of deaths associated from these heat waves was still a lot of underestimations. But again, power plants having to reduce their output because of low river levels. Again, there were prolonged drought periods or dry periods preceding these heat waves. France experienced temperatures over 45 Celsius for the first time. And it was reported that any anthropogenic global warming that we've attributed that's been going on has led to the temperatures to what they reached. If we didn't have this, temperatures during these heat waves would be 1.5 to 3 Celsius below normal. We've kind of talked about already, alluded to the heat waves of 2020, which typically happened in August. And then we've had the extreme one that happened early August in Southeast Europe, of which Sicily saw 48.8 Celsius, which we're still waiting to see if that actually verifies. And really, with the future of heat waves, we're going to see them more likely happening, and they're going to happen differently than what we've already experienced already. And large part is, I attended the atmospheric virtual blocking workshop last month, and they said those are going to decrease, and that's one way you get your heat waves. So where I think our heat waves are more or less going to come, based on the WMO definition, is you're going to see maybe not true extreme heat waves like we saw in 2019 or what we saw earlier this year, but we're going to see more prolonged periods where the average high temperature is 4 or 5 Celsius above normal. Examples this past July, which happened to be one of the warmest in Europe without any true extreme heat. And with that, I will take any questions.
Brilliant, thank you. Very interesting, and a great summary. Both, different parts of the world thinking about the definitions of heat waves. And we've actually got one question just thinking about heat waves themselves and those definitions, because obviously as climate changes, those temperature averages are changing as well. And so it's a kind of question around the threshold that we have. So we've got these different definitions based on specific temperature thresholds as opposed to kind of average past temperatures. And obviously as things change, is this a confusing message? Do you think generally definitions of heat wave, Tyler, are quite confusing? Because you say there's lots of different ones depending on where you are in the world.
If we're talking on a global scale, they can be. But if you're in one particular location and it's one that you've always grown up with, I don't think it's necessarily confusing. So let's say you've always grown up in the London area, and it's always reported that it's always going to be 28 Celsius is the criteria for 3 consecutive days to be considered a heat wave. That might be drilled into your head. I know that's drilled into our heads in the United States, where that's always a talking point. When you see 3 straight days of 32 plus, they always say that's an official heat wave. So will those values have to change down the road? Yes, under the warming climate. We can't continuously say 32 Celsius here in the Northeast, but yet those become way more common. That's where we might get into a little more confusion with some of the older population still under the mindset that it is in, let's say, a 32 Celsius when it moves up to maybe 35 Celsius in that regard.
Yeah. A comment from Gerald, and I'll kind of lead on from his comment to a question, but he really likes the format of the US weather warnings, very easy to read and understand, well structured, same with weather presentations. And I was just interested, obviously you use the feel like for heat warnings, which we don't tend to do that in the UK. We do for cold. So we often in our TV forecast talk about feel like when we've got a wind chill factor, but not really with heat. So I was really interested to see how you use that, and maybe, how receptive are the kind of general public to understanding that? Is that something they're used to?
Yeah, here in the United States, it is one thing that everyone goes to, is that's kind of, we might not necessarily say, all right, the temperature reached 32 or 33 Celsius. We're going to say, well, it felt like it was 35, 37 Celsius outside. And it's kind of something to say, yeah, it did feel that very hot. Or in the case of some locations in the Pacific Northwest where it lacked the humidity, what you read outside on the thermometer actually matched what it felt like outside. Yeah. So those are different things that you can play to say, yeah, you need to really, if there's going to be high humidity, you really have to stay hydrated, versus like if it's near the temperature, I would say what you have to do is a little bit, probably lightly less than if you had higher humidity, for instance.
Yeah, and humidity is just as important, isn't it, as the temperature, because it's how your body reacts. You know, if it's high humidity, your body can't perspire quickly enough to cool itself down, whereas if it's drier heat, less humidity, it has a better chance. So, and as I say, in the UK, we tend to focus on temperatures when they're high rather than the humidity, so maybe a lesson for us to learn. But thank you very much, Tyler. Really interesting presentation. And I'm going to move back to our second speaker, who I introduced a little bit earlier. So I'll invite Joe to the stage, and I won't reintroduce you, Joe. I gave a brief introduction, but I'll let you move into your presentation. So if you could put on your camera and your microphone. I don't know if we've got the same problem again. So I'm struggling to see you, Joe. Okay. I don't know if you can switch your camera on and off. That might help. Or maybe try leaving the stage and joining again. So Joe, if you could just try joining us on the stage again. Okay. We will get to Joe, I'm sure, in the course of the event, but I'm going to move on to the next speaker that was on our program. Oh, no, Joe's back. Joe, can you just try switching your camera on and unmuting your microphone? Okay. I don't think we're working. I think what we may do, Joe, is actually move your presentation till after the break, and we'll try and fix the technology over the break and come back to you later on in the program. Okay. Great. Okay, so I'm now going to move on to Mark Parrington, who is a senior scientist in Copernicus Atmosphere Monitoring System, or CAMS, which is part of, based at ECMWF. And Mark Parrington holds a DPhil in atmospheric physics from the University of Oxford and has got more than 15 years experience of working with Earth observations data. So we're going to focus now on wildfires, something we've touched on a little bit when we had our presentation from Chris, but we're looking at how we kind of monitor extreme global wildfires. So I'm going to hand over to Mark for his presentation. Thanks, Mark.
Okay, thank you. Can I just check you can hear me okay?
I can hear you and I can see you. Great.
Okay, great. Thanks very much. Okay, thanks, Liz, and thanks to Royal Met Soc for arranging this event and giving me a chance to give a short talk on some of the work I've been doing at ECMWF as part of CAMS in relation to fire monitoring. And before I start, I'd like to acknowledge various co-workers who also contribute to this work. Okay, so I'm going to give a very brief introduction to who we are, who ECMWF is, and what the Copernicus Atmosphere Monitoring Service is, and then move on to give a bit of background to what we mean by wildfires, why it's important to monitor them, and then give two examples of really recent years, very extreme events. So, and Chris already touched on these in his presentation earlier, which would be the fires in Australia at the end of 2019, 2020, and also fires in the Arctic and the Arctic Circle before wrapping up. Okay, so very, very brief introduction. So ECMWF is the European Centre for Medium Range Weather Forecasts. We're an international organization, and we focus on the medium range weather, which is 5 to 15 day, forecasts. So we've been in place since 1975, and we're based just outside of Reading. And we also, as well as the weather forecasting, we're also involved more and more in Earth system modeling, and atmospheric composition is a part of that, as is climate change and various other activities. And a lot of these activities come under the Copernicus program. So Copernicus is the European Union's operational Earth observation and monitoring program. It provides free and open access data. This is from satellites, so those are shown in kind of silhouette there on the left. And these data feed into data services, which makes the data a bit more accessible, a bit more usable for people. And at ECMWF, we implement the atmosphere monitoring and climate change services, and we also contribute to the emergency management service, which is through flood forecasting and fire danger forecasting. But I work in CAMS, and our mandate, if you like, is really to focus on all aspects of atmospheric composition and air quality. So we have a wide-ranging portfolio of various products, which include surface emissions and fluxes of fires, like I'll talk about, but also from human activities. This feeds into global air quality, European air quality, and our data can be used to look at things like the ozone layer, solar radiation, ultraviolet index, greenhouse gases, and various other things. And more information is available through our website there. But I think in the interest of time, best to get on and to start with a bit of background about what we mean by wildfires. So wildfires is a term which really, in the way I use it, is a catch-all term for any kind of sort of open air vegetation fire that's then ultimately detectable by a satellite. But it could cover a wide range of different things. So here's some examples shown with some visible identification. So at the very small scale would be things like debris clearing, and this is often used for agriculture around the world. So for example, right now, northwestern India, we get rice stubble burning, and this also causes air pollution impacts throughout the Indo-Gangetic Plain. And then going up in scale, things like grassland fires or even savanna fires, these are typically in the tropics, but we also see them across Europe and across North America and in the UK as well, indeed. And then within forest fires, there's a couple of different types of fire. So there's the sort of below the canopy fire, which are the ground fire, which burns the vegetation on the ground. And then at the bottom right, the images that I guess most people are familiar with when we talk about fires, which are these crown fires where everything's burning and they're very dramatic and very dangerous, producing lots of pollution and the impacts that they have. So in terms of pollution, fire, burning vegetation in general produces a lot of different types of pollutants. So these are aerosols, or particulate matter, so soot and carbon aerosols. Anybody burning garden waste, for example, will know that the smoke that you can see, this is the particulate matter and the aerosols, but also various gases. So carbon monoxide is a product of incomplete combustion. It's not the most dangerous pollutant in itself in outdoor spaces, but it's a long-lived gas that gives us a good way of tracing then the smoke and where the pollution impacts might go. And then there's various other pollutants, and a lot of this is very toxic and very hazardous to human health. And so it's important that we have good estimates of fire emissions and then also the smoke impacts and air quality. And as well as air quality, things like aerosols from biomass burning and smoke can impact on weather and climate. So they can affect how solar radiation passes through the atmosphere. It can affect the optical properties of clouds. The actual impacts are very varied and very nuanced. And I don't want to go into those right now. That could be a whole hour's talk in itself. But just to point out that at ECMWF, we can also couple our smoke and fires to our weather and understand then what the weather impacts of smoke could be, as well as the air quality impacts. What we're concerned about in terms of air quality impacts is in terms of human health. And again, Chris touched on this a little bit in his presentation. And here's just a couple of infographics to kind of illustrate that a bit more. So as well as the typical respiratory illnesses that you might think about when inhaling smoke and air pollutants, it also leads, smoke particles can also get into the bloodstream. It can also affect the cardiovascular system. And so there's a lot of research that's going on right now to really understand and really get to the bottom of what what the health impacts are. But these are some of the main ones that are known about at the moment. And more information is given on the links on this slide. In terms of the risks from an air quality index point of view, so an air quality index is a way of compiling the concentrations of different pollutants into giving just one number that then gives you a sense of how healthy or unhealthy the air is to breathe. And this is a chart that shows the increasing risks for heart disease, lung disease, diabetes, as that air quality index increases when you have a fire event. Okay, so that's a very quick run through of why the motivation. This is why we want to understand wildfire emissions and why we monitor them. And I'm going to talk now about what we do in CAMS and lead up to those examples. Okay, so we estimate wildfire emissions based on satellite observations of a parameter called fire radiative power. So basically a fire intensity measurement that's available in near real time from satellites. There's a number of satellites that provide this in real time, and we can use that information then to initialize every forecast that we make each day. And this is in a global sense. So we have global coverage at about 10 kilometer resolution. And we have a way of sort of tracking the daily profile of fire activity using different satellites, and more information is given on the slide here. And in addition to those satellite observations of fires, we also have various other satellite observations related to atmospheric composition, and this can also relate to the smoke. So we can use observations to initialize the fire emissions, but then we can use other satellite observations to then constrain the model, provide the optimal information for understanding then the smoke transport and what the wider air quality and atmospheric pollution impacts could be. And this is just a table to give you a sense that there's a lot of species, chemical species that we use data for, and a lot of satellite instruments that provide that information. So let's have a look at fire. So I'm going to start off in the global sense, and this is a time series of daily total estimated fire emissions for 2020. So from the 1st of January through till the end of December. The red line is the data from 2020. The black line is an average of the data from 2003 to 2019. And the gray lines give us a sort of sense of the minimum maximum values for each day. So we can see there's this very clear cycle peaking in the summer months. And the red line is generally below the black line for most of the year, which means that at the global scale, fire emissions were reduced. But then there's isolated areas and particular regions where the fire emissions were much, much greater than average, and particularly in Australia. So we see at the beginning of the year, this big spike in the red line, which is the bushfires in Australia. We can also total these over the whole year and look at then the total emissions of carbon in this case, but this would be true of other pollutants. And we see, looking at our data set, which goes back to 2003, generally a decrease in the global total emissions and the number of fires. And this is mostly driven by declining numbers of grassland and savanna fires in the tropical regions. So the tropical regions are vast areas, large numbers of fires in those grasslands every year, but that's actually been declining over the last 20 years or so. If I then switch to have a quick look at the same kind of data for this year, going back to the beginning of 2021, this is a similar kind of time series as the previous slide. This time the black line is an average of 2003 to 2020. And in this case, again, you see the red line generally below that black line with the 2021 data, apart from in July and August, where we see this really huge increase in the global total daily emissions. And this is driven by fires in Siberia and North America, which were burning at the same time. And then this is sort of updating that time series, but we see we still got a couple of months to go in the year. So this number will increase a little bit, but it's generally looks like it'll be in line with that declining trend over the previous 20 years or so. And then this is kind of what it looks like in a global distributed sense. So this is looking just at July data, 2020 on the left, 2021 on the right. The red dots are showing the observed fire locations throughout the whole month. And they sort of colored based on the intensity. What we see is typically in the tropics, sort of seasonal fires in South America and southern tropical Africa. But then we see, if we look at the northern hemisphere, in both years over sort of eastern Siberia, large areas of persistent fires, and then also in 2021 over North America. And as we've seen in California and western parts of Canada, severe fires throughout the summer. Okay, so that's a summary of the current global sense, if you like. What I want to do now is go into looking at these case studies. So I'm going to start with Indonesia and Australia and then go on to the Arctic. And I'm going to just show for Indonesia, this is from 2015, just some visual examples of what was the most extreme fire activity in recent years. So this was related to the El Nino in 2015, really severe fires that burned for several weeks in Indonesia. So these are satellite imageries from the Himawari 8, which is a Japanese geostationary satellite. On the left is July the 3rd, 2015. So a very clear view over Borneo and Kalimantan. And on the right is what it looked like then in the 20th of October. So these fires in southern Kalimantan really producing lots of smoke, which hung around for ages. And this is the haze and very clear in satellite imagery. And then this is what it looked like from the ground. So this is the middle picture is an image taken from a field in a plantation in somewhere near Palangkaraya in Kalimantan. And then the bottom right image is a photograph of a PM 2.5 sensor, which is showing more than 3,700 micrograms per centimeter cubed of PM 2.5. The WHO, EU thresholds for PM 2.5 exposure is about 50 micrograms per meter cube. So this is several times higher than that. And one of the reasons these fires were so extreme was it was peatlands that were burning. The fires could burn underground, smolder at low temperatures, and just constantly produce pollutants, which just hung around under those conditions. And like I said, this was really driven by this strong El Nino in 2015. So this is a chart now showing for Indonesia, the daily total fire emissions just for that country. And if you can make out the yellow bars on this chart, those are the data from 2015, so the El Nino year. In 2019, we also saw, in the red line, we also saw high fire activity, not related to El Nino, but related to the strong positive phase of the Indian Ocean dipole. So what the positive phase of the Indian Ocean dipole means generally cooler but drier conditions in the maritime continent and also in Australia. And this sort of linked up then with the fires that we saw in Australia through late 2019 into 2020. And that's indeed what happened. So this is data looking at August 2019. So the chart on the left is from the Australian Bushfire Natural Hazards Centre, and they showed, particularly over southeastern Australia, very high fire danger conditions. And then the panels on the right are showing climate anomalies from the Copernicus Climate Change Service, and these are soil moisture anomalies. So where it's red means much drier grounds and much drier vegetation than the climatology. And then that led to these fires. So these, there's a lot of information on these slides, but the top two panels, a chart showing the daily total fire emissions for New South Wales and Australia as a whole from the beginning of September through till the end of October. And then the two panels immediately below are showing sort of the continuation from the 1st of November through till the end of February 2020. And so what we see is this change in the scale and most of this fire activity was really being driven by what was seen in New South Wales and Victoria. And then this produced a lot of smoke, which was then affecting air quality over Sydney and Melbourne, as was shown a little bit by Chris, but also that smoke spread right across the Southern Ocean, reaching as far as South America. And so these are just a couple of examples to show. The maps are showing organic matter aerosol optical depth. So this is like a measure for smoke. And the red and yellow values are where that value is high. And we can see that spreading across the Southern Ocean, reaching New Zealand and out to the Pacific. And then the panel in the middle is showing a quick evaluation. So the top panel in that little square is measurements from a satellite called CALIOP, which is basically a LiDAR that's measuring cloud and aerosol properties in the atmosphere of high resolution vertical profiles. And then below that is the output sampled along that orbit from our model forecast. And so we get this aerosol layer at about the right altitude and roughly in the same sort of magnitude. And then that was from the 4th of January, and this is from one day later, the 5th of January, so very similar things. So actually we captured this smoke in terms of the height and its distribution quite well. And then also we have a product called a reanalysis. So we have a long time data set that's self-consistent, and we can then look at anomalies. And this is looking at carbon monoxide and aerosol optical depth anomalies for January 2020. And what it's showing is across the Southern Ocean between Australia and South America, persistent high increase to the background of atmospheric pollution related to the fires. And one thing that was interesting with these fires, that smoke actually getting into the stratosphere. So again, this is an image from a NASA study, which then looked at this CALIOP data again, so LiDAR data. We see the smoke in the stratosphere. And this was also observed by an instrument called the Microwave Limb Sounder. So this is looking just at the profile of the atmosphere, mostly in the stratosphere, and we could see then very high values of carbon monoxide from the aerosol and also from the carbon monoxide from the fires, excuse me. Okay, so I'm going to move on now to look at the Arctic fire. So in 2019, 2020, we saw very large scale and persistent fire activity north of the Arctic Circle in Siberia, and also in parts of North America in Alaska. And again, these are very complicated slides, so just very quickly walk you through it. On the top left is the daily time series of, this is the fire rated power, so basically the intensity. In red is the 2020 data, and yellow behind it is 2019. So we see from the middle of June through till early August, this really high, persistently high values day by day. And then the chart on the right is showing the cumulative total emissions for the Arctic Circle. So we see in red and yellow the 2019-2020 data well above the average. And indeed, there's a blue line on there, if you can make it out, which is 2021, and shows that for the Arctic Circle, at least it was much lower, or more typical values for the Arctic, although Siberia itself was at a much higher values, but I won't talk about that. And then on the bottom left is then the total estimated carbon emissions for the Arctic Circle from 2003 up till 2021. This is for June, July, August. And we see 2019, 2020 really standing out. So I'm going to skip a couple of slides in the interest of time. What this chart is showing is then the distribution of the fire activity around the boreal zone in 2019, 2020 on the left and right there. And the shaded colors behind are the soil moisture anomalies. So what we're showing here is that the red dots, which are the observed fires, mostly occur where the soil moisture was drier than climate, which meant warmer, drier conditions, and to the ideal conditions for fires to burn. And this is also backed out then by the surface air temperature anomalies over Siberia particularly. And this could be related to the weather in the position of the jet stream through things like the geopotential height anomalies. And generally what happens when we see this positive geopotential height anomaly, so that is to say that the jet stream has been moved to a position that then favors sort of hotter, drier conditions, is where we see the fires in those regions. So this is showing 2019 and 2020, the positive geopotential heights in red, and then the associated fire activity. And then if I switch that to then look at the smoke pollution from those fires, we see really widespread distributed smoke through July of each year in relation to those fires. We also can do some evaluation, and this is just a quick example from Yakutsk, the city of Yakutsk is right in the center of Siberia, really heavily affected by these fires the last 3 years. And we capture generally the amount of smoke in our model quite well. The chart just on the bottom right, I'll draw your attention to the blue dots are observations from the ground, and then the red line is our forecasted aerosol. And we see that generally when it peaks, we capture the peak and the magnitude quite well. This is just one example, but I have other months that show a very similar picture. And with that, I'll come to my summary. So hopefully I've given you a sense of the extremes of fire around the world and how we monitor them. Of course, we do this in a global sense, so we can focus on different regions, different countries. And I didn't have time to talk about it, but there's a whole wealth of additional information that's available for really getting context and understanding these fires, why they burn in this way, the smoke that they produce, where that goes and who else it might affect, also how it affects the weather and climate. But that's for another talk. So I'll thank you for your attention and take any questions.
Fascinating. Thanks, Mark. Excellent talk. So I've got a couple of questions in the chat. The first one talks about where smoke from wildfires actually goes. So the specific question is, does it cross into the other hemisphere? And I think you started to kind of show, obviously, track of smoke from wildfires or aerosols or pollutants. I guess, could you give us an example of something where you've seen a significant track of the smoke from wildfires?
Yeah, so it's typical during the summer months with boreal fires in North America that smoke crosses the North Atlantic, reaches European airspace. And indeed, we've measured that with aircraft and balloons and from the ground when that happens. That's a reasonably common event. You get 2 or 3 maybe events per year. This last summer, excuse me, the fires in Siberia really produced a lot of smoke. It was very similar to what we saw for the Arctic, but just south of the Arctic Circle. We saw smoke crossing the Arctic Ocean, reaching the North Pole, and in fact crossing the North Pole and reaching the north coast of Canada. And again, there's some element of Arctic smoke transport each year, but this was really an extreme case where we see this. See also the impacts in atmospheric radiation and surface temperatures reduce. Well, in the sort of positive sense, if you like, it sort of reduces the surface temperatures, but then it also increases risks of things like soot deposition on sea ice, which would accelerate the melting by changing the albedo. So there's a lot of cases where we see this long-range transport, and also that Australia case, we saw that smoke when it gets in the stratosphere really stays around for months and just sort of recirculates and just before it finally degrades and disappears. So yeah, there's a lot of cases of it, and it depends. Some of it will depend then also on the pollutant, how you look at the smoke. So carbon monoxide has a lifetime about a month, so it really tracks this smoke over sort of intercontinental scales. But then other things which are a bit more reactive are much closer to where the smoke is, so it's more directly impacting air quality in the local area.
How easy is it to distinguish between wildfires and emissions from volcanoes? So obviously we've got La Palma at the moment. It's producing an awful lot of emissions, which I know obviously CAMS you're able to track and monitor. But how easy is it to kind of distinguish one from the other?
The relative amounts of concentration. So for the volcanic eruptions, it's mostly sulfur dioxide that we're able to detect from satellites. But it's true that the way the satellites work for detecting fires, actually they detect a heat source at the surface. So we do have essentially fire emissions estimated from the volcano, even though they're not fire emissions. But yeah, it's possible just because we know that from volcano you get more SO2, and then from fires it's more carbonaceous aerosols and carbon gases. In principle, you can then sort of break it down, even types of fire, you can by looking at ratios of different chemicals and pollutants, but we're not able to do that with satellites, but in principle it's possible.
Great, thank you, Mark. So there are a few more questions in the chat, which if I could get you to actually just try and answer them in the chat, that'd be great. There is a question from Richard, which I'm probably going to say for our next speaker, Will Lang, because it's specific to kind of weather warnings in the UK, but feel free to put your own comment in. But a big thank you to Mark. What we're going to do is move the programme around a little bit. So I'm going to invite Will Lang up to the stage next. Will was going to talk after the break, but we're going to set Joe's camera and speaker up over the break so we can come back to Joe's talk after our short break. But I'm going to introduce Will Lang, who is Head of Civil Contingencies at the Met Office. So Will leads the Civil Contingencies Services and the National Severe Weather Warning Service, the NSWWS, which I think has been around now for just over a decade. And we're going to talk about that today. So talking about warning of extremes in the UK. So I'll hand over to Will.
Thanks, Liz. Hi, everyone. Can you hear me?
I can hear you fine. Can't see you.
Okay. Good afternoon, everyone. Yeah, I'll say a little bit more about myself. My background is in weather forecasting at the Met Office. And as Liz said, I lead the National Severe Weather Warning Service now. So I'm going to talk a little bit about how that works and some of the challenges we face using some real examples. I'm also going to talk about how we define and identify extremes, both in a meteorological sense and in terms of an impact sense. But as well as that, I'm also going to talk about how we communicate risks of those extreme events in a useful and beneficial way, and indeed what we mean by useful and beneficial in that context. But I'm going to start by comparing and contrasting two recent events. First of all, I'm going to start off with a wet summer's day in Norfolk in August 2020, so just over a year ago. Now, for those of you listening from outside the UK, this part of England in the southeast is particularly prone to summer thunderstorms. It's pretty normal to have many days of summer thunderstorms there. Now, as I said, I'm the head of the warning service, and myself, my colleagues and the other forecasters, we saw nothing especially unusual on that day. It was another warnable summer thunderstorms day, but nothing particularly extreme. And we didn't see anything extreme in terms of our real-time rain gauge network during the afternoon and evening itself. Now, it was only when the additional rain gauge information started to arrive after the event. So this is the daily measurements and the things that are from others other than Met Office rain gauges. Now, it was only then that we did see that something remarkable had happened that day. There was a gauge just outside the small village of East Wretham, right in the middle of Norfolk, which had seen nearly 240 millimeters of rain in just a few hours. So that's a new August daily record once we verified that. In fact, though, it's really off the scale in terms of our contextual frame of reference and indeed our standard class, what you'd expect out of any kind of rainfall event. 200 millimeter rainfall events are usually graphic events in Cumbria or Western Scotland or other hilly areas in the UK. So getting a convective event like that is extremely rare. But really, there weren't any impacts. The actual were incredibly localized, probably just to a few square kilometers. There was some surface water flooding of the minor variety more widely across Norfolk from just those general thunderstorms across that whole area. But really, what worked in our favor here is that it fell in a largely unpopulated and rural area. It was flat, it had good drainage, sandy soils, etc. So really nothing happened. So that's an extreme weather event with no impacts to speak of, really. But then more recently, well, actually, we've had a string of surface water flooding events across the London area over the last few months. We've had 4 of those kind of events, and the last one was just over a week ago in the early hours of Tuesday, the 5th of October. And what we had here was a cold front crossing west to east across England, past the London area in the early hours of the morning. It had some embedded line convection within it. And the rain gauges started to pick up 20 to 30 millimeters in less than an hour, which is heavy, warnable rain. But it was certainly enough in this case to cause a few hours of chaos in Kensington and other parts of central London. And this is a much more vulnerable area for various reasons. I mean, there's really nowhere for the rain to go except for places like tube stations and very, very disruptive for a much less high rainfall total. So the point I'm trying to make here is that there are weather extremes which have no impact, and that could be extremes of rainfall, wind. Have a really, really deep low pressure system, which is a record-breaking low, for example. And again, no impact if it doesn't happen in the right place, if it doesn't affect the right place. Conversely, extreme impacts from weather which is not meteorologically extreme, and that London case is in point, where we have somewhere which is particularly vulnerable for certain types of weather. Now, however we choose to define it, we've seen from previous speakers, and we know that these extremes are becoming frequent and more extreme. And we've seen many other examples across the world this summer. So we've seen the severe flooding in Germany and Belgium. We've seen the effects of Hurricane Ida on New York, again, flooding, and also in China. We've already talked about heat waves, we've had them in the UK, but also the heat waves and wildfires in the USA and Canada. And it's pretty clear, and this was highlighted by the Environment Agency report, it's really only a matter of time until we get this kind of extreme impact event here in the UK, not just for flooding, but other types of weather too, including heat. So we really need to be prepared in terms of the way that we plan for these events and then know how to warn for them. So Tyler gave us that really great overview of heat waves earlier. Heat waves we've had in UK in recent years. This year we launched that heat warning and we issued the first 2 warnings in mid-July. And when we did that, lots of people asked us what methodology we'd use, particularly colleagues in the broadcast media, how we arrived at the actual warnings that we ended up with. And it wasn't based on where the highest absolute temperatures were. What we did in this case is we started off by looking at where the heat was most unusual geographically and also how long that lasted. So we really were looking for something where the heat lasts several days and more importantly, those nights in between as well, those tropical nights where there's no break from the heat. And we're looking for those areas where people and services are just really not used to it. So the graphic on the right there shows the day-by-day maximum temperature anomaly during that period in July. And the darker the red, the more unusual it is for that particular location. So dark reds and purple, that kind of heat is most unusual. And if you just move through the sequence from top left to bottom right, you can see it does focus on western parts of Great Britain and particularly Northern Ireland later on in that period, which turns dark purple. And so that was really our starting point for the warning decisions. We took where the weather was most climatologically unusual, and then on the basis of that, we undertake an impact assessment, and I'll come back to that shortly. But again, we're looking at off the scale extremes here. To have several days of 30 Celsius plus in Northern Ireland, that is one of those things, and this is a phrase that has occurred again at those other summer events, something that's virtually impossible in the usual climate that we've been working with until now. So something is changing. These are the warnings we actually ended up with. So meteorological advice and the anomalies, we then undergo a lot of discussion behind the scenes across government and across health agencies in particular. So factors we take into account are things like pressures on hospitals, emergency services, that it was the middle of summer, people on holiday, etc., many other factors, COVID factors, and that eventually resulted in the 2 amber warnings that were issued that week for parts of southwest Britain and also for Northern Ireland. So again, that weather extreme, the meteorological, not based on the absolute temperatures, and then that meteorological extreme is just the starting point for that warning discussion. So that's a good opportunity then to take a step back and look about how our warning service works in general in the UK. And many of you will know this. We have 8 weather types, either individually or in combination. We have 3 colors, yellow, amber and red, reflecting increasing risk, and we can areas up to 7 days ahead. The most important aspect, fact-based warning system. So we start with that meteorology, then usually working with partners, we work out the impacts which may occur onto our risk level and color. So it's all about the impacts, not necessarily about the meteorological extremes. It's about the effects of the weather on people, properties, communities, infrastructure. And that's how we'll judge the warnings. It's also why there are no fixed thresholds. So in a sense, the argument about the precise meteorological definition of a heat wave is almost irrelevant when we get into warning territories, because it's really all about the impact rather than fixed meteorological values. It's also worth mentioning that this methodology has really become the WMO standard for warnings worldwide. This risk-based methodology, there are several variants of it, but it also fits into the way that the UK government plans for risk. So there is something called the National Risk Register, which contains all the weather-related risk, but also many other hazards and threats which could affect the UK as well. And it shares a common methodology with that system. So once you start to think about warnings in that way, and this is what we've done both in the UK in the Met Office and internationally in WMO, it makes you take a step back even further still and think, what's the point of warnings? Or what's the point of a government investing in a weather service and a warning service? And it's really more than just giving people some indication of bad weather on the way. It's really about taking weather information and making it useful in terms of societal benefit. there has to be some end result to mitigate the risk in terms of people using that information to take action to protect themselves, their families, their communities, their businesses, etc. So we like to break it down into a chain of things that have to happen for that meteorological information to be translated into that benefit. And we start with reach. We have to get that information out as widely as possible. We have to do that in a way which is accessible to people, given the channels that are available, TV, internet, etc. We have to make sure it's reaching the right people, the people who are most at risk, the vulnerable. And we have to make sure that people can notice that it's there, that it's sufficiently engaging and visible. Then they have to trust that information. They have to think, well, actually, that's credible. I'll take that seriously. Part of that is brand trust. So, you know, we like to think that the Met Office has a strong brand in terms of trust around severe weather. So we put a lot into building that. And also we're aware that there is a whole landscape of other conflicting weather information, and some of that will be perfectly fine from you know, other weather providers. There'll be a lot of fake news out there, or just stuff which is just irrelevant. So it needs to stand out and be trusted. Then people need to understand that information, and they need to know really how it will affect them. So they think, actually, you know, I can visualize what this might do to myself, and actually, you know, that's part of the understanding process. And then that is a step just to saying, what action do people need to take? Do people know what action they should take if it's really windy, really wet, snowing, etc.? Do they understand what benefits might be achieved by these actions, even if they're just modest actions, like making sure that your drains are unblocked, for example? And then do they have the confidence to actually take that action? So it's not just a theoretical thing, it's something that people actually do. And traditionally, the focus of weather warnings is really focused on the left-hand end of that chain, but to be really effective, it has to work all the way along that chain, and we have to deal with all of those elements and make sure that we've got all of that covered. Professor Brian Golding talks of the valleys of death in the forecasts and warnings value chain. And what he means there is that all of that benefit can be really lost on that path to helping people take actions if you fall down at one particular element, if you're not trusted, if your warnings are not understood. So going back to extremes, where we think that something bad might happen, what we're really doing with a warning and all the communications that surround the warning is building a case for people to act. And that has to be accessible, engaging, plausible, trusted, relevant, etc. And one of the key ways that we've learned to do that, and we do it really well, I think, in many weather services around the world, we've got really good at using people's personal experience of how the weather has affected them in the past. So most of us will have a mental catalogue of at least a handful of weather events which have affected us personally during the course of our lives. And, you know, that would be things like Beast from the East, 1987 storm. We'll have also seen high profile things on TV, maybe relatively close to where we live. So I live in southwest England. I can remember the Boscastle floods being on TV, and that's not too far away. So what we're trying to do is build this contextual catalogue of events that we can tap into to trigger this understanding and action. And really, storm naming is a crucial part of that. That's a really effective tool to give something a name that people can latch on with, and then think, oh, yes, I remember, well, storms Kira and Dennis, as we heard earlier on, Storm Desmond, etc. So that's a real important communication tool. And then once we start to build up those communication tools, that builds engagement and understanding, and then triggers that. But we have a problem here, is that really the baselines for extreme weather are changing really, really quickly. And it may well be that past events are no longer a reliable or useful guide to future events. We just simply don't have that context. I don't think any of us has had the context of being in a 200 or 240 millimeters per hour rainfall event, or just in a few hours, that occurred in the middle of Norfolk, but more importantly, similar totals happened in New York and in parts of Germany and Belgium. We just don't really have a feel for that, about how that will affect us and how we need to react. So we do need to find new ways of not just modeling these things, these extremes, but finding new ways of communicating the risks and understanding how to communicate with people about what they should do in those kind of situations. So this leads us on to where we're going with warnings in the future. I mean, clearly we need to be future-proof for that future climate, and the warning services itself that we use need to keep up with that changing climate and the increase in severity and frequency of extremes. And that will be things, you know, it have to include intense rainfall, surface water flooding, and extreme heat. But you know, many different types of weather are changing in their frequency of extremes. So that leads to the question, do we just issue more warnings? And there are problems around that because people only have a limited tolerance for a number of weather warnings, and they tend to get warnings fatigue. So do we raise the bar and basically say that there's a whole level of warning types of event, which will potentially be impactful, but we're just not going to warn for anymore? So that's one of the discussions we need to have. We've seen in the last 18 months that there's a much bigger focus on concurrency of risk. So we're getting these weather extremes happening at the same time as other things. And that might be other weather events, but it also might be things like the pandemic, or in the UK, concerns around supply chains, for example. So this all needs to be factored into the warning service in the future. But really, again, thinking of those valleys of death and that value chain, we need to build much greater awareness of extreme weather, people's vulnerability to severe weather, and how they can protect themselves. So what we're trying to do with the warning service in the UK over the next 5 years is put a much greater focus on advice. Not telling people what to do, but giving the people the advice so that they know that they can make the decisions to help protect themselves. So Liz mentioned that the National Severe Weather Warning Service has been in its current form for 10 years. That's when we took this impact-based methodology on from the old threshold-based system in 2011. And as I said, we've been pretty much become a world standard for defining how that works over the last 10 years. But we're now looking ahead, and 3 or 4 years' time, 2025 onwards, and we now want to set a new standard for warnings in the UK, which will hopefully be used worldwide as well. And this is about action-based warnings. So going beyond what the weather will do to how you can act to protect yourself from the weather, your family, your community, and the whole of the UK. Thanks very much. Liz, I can't hear you. Yeah.
Can you hear me now? Great. Yeah, a couple of questions in the chat around the different categories of warnings. So do you envisage in the future that we might start warning for wildfires, for example, or for space weather? So if we get a big solar flare that might kind of take out comm systems, GPS, do you think the Met Office might give National Weather Service warnings on categories like that?
Around things like wildfire and space weather. So it might well be that we have some kind of warning service, might not necessarily be directly from the Met Office, but something we'd contribute to.
Great. So another question around the heat wave warnings. So obviously it is linked to temperature, but the decision around that and the fact that it's linked with impact, is that because we know at a certain temperature, firstly, yes, you know, the increased mortality rate goes up, so the impact obviously on people's lives is greater. And can I just throw something else in around COVID? Do any of the warnings have they changed because of where we were with COVID in various lockdowns? So did you have to consider that and the impact of COVID as well?
So in England, that would be UK HSA, as it's now called, PHE as was. So we work very closely with the team there. They have a wealth of statistics about what happens when it's hot at certain temperatures. So there's a very robust base of evidence around the link between temperature or mortality, and it's pretty frightening. You know, there was like 2,000 extra excess deaths in the heat wave, the extended heat wave last year. So that's the biggest single factor, but we'll chip in about things like, you know, damage to infrastructure and power supplies, etc. So we factor all of that in. The second point was, oh yes, do we change the decision making around COVID? Well, we considered it, whether it actually shifted the bar one way or the other. But again, it's about snow warnings, for example. We do take into account and discuss across government, are there any additional pressures on, you know, people queuing outside vaccination centres at the time in midwinter? Like I said, I don't think it decisions like one way or the other in the last 18 months, but it is part of that set of factors that we need to consider.
Yeah. Great, thanks, Will. There is another question from Gerald. I'll get you to probably answer that in the chat if that's okay, but I'm conscious of time and I'd like to just give people a break before we kind of move on to the next presentation. So we're going to take a short break, enough time hopefully for you to just take a comfort break and put the kettle on and make yourself a cup of tea and come back. So hopefully we can come back just before 3 o'clock. And in the meantime, we're going to try and fix Jo up so we can see and hear her and go back to her presentation and show a short video as well during the short break. So if you can come back just before 3 o'clock, that would be great. Speak to you then. Okay, well, welcome back, everybody. I think, Jo, your camera's off, but I'm hoping we can hear you. So I don't know if you would mind just trying to use your microphone, see if we can hear your audio. I can't hear anything at the moment. Maybe if you could switch your microphone on and off, that might resolve that. You could try unmuting your microphone. I still can't hear anything. Okay, so welcome back, everybody. I think what we're probably going to have to do is bring on our next speaker, David Warrilow, and we'll come back and see if we can reconnect Jo after that. And if we can't get Jo's presentation to run live, then we'll ask Jo if she can do a recording and share that in slower time with everybody on the call. But I'm going to invite David Warrilow to the stage if I can. So David Warrilow is a recent past president, actually, of the Royal Meteorological Society. I certainly had conversations with David when he retired from government a few years ago and invited him to get involved with the work at the Royal Meteorological Society. And, well, you've been an active volunteer, certainly, over the last 5 years or so. So, David, originally started your career at the Met Office, but for most of your career, you were based up in government and a senior government science advisor and international negotiator on climate change and environmental issues. You've led the UK delegations for the IPCC, the Intergovernmental Panel on Climate Change, and the science lead for the UK and EU and in the UNFCCC, the United Nations Framework Convention on Climate Change. And David's here to kind of demystify what COP is. We probably all heard about COP and COP26 that's about to take place in Glasgow in a couple of weeks' time. And David and I will both be up there for COP. So yeah, David, over to you for your presentation to demystify COP.
Thank you very much, Liz. I hope you can hear me clearly.
I can hear you fine.
Fine, good. Okay, so this will be a quick rattle through what the Conference of the Parties is about. So let me just go to my first main slide. So I'm just going to say, look at what is it, how does it work, what actually happens during the meetings, and what's the aim for the one that's in Glasgow at the end of the month. Well, COP is Conference of the Parties, and parties are just countries that have signed the UN Framework Convention on Climate Change. So that's what COP stands for. And COP26 is just the 26th in a series of meetings, pretty well annually, in which 198 parties can agree to take forward actions to deal with climate change. So that's pretty well all the UN countries across the world. Now, the Framework Convention was agreed at Rio de Janeiro in 1992, and it was set up to be a framework for addressing climate change. And the aim was always that there would be an additional agreements based on it. Now, the first conference of the parties was in Berlin in April 1995. You might wonder why it took from 1992 to 1995 to have the first main meeting. But if the way the UN system works is you have a period where countries having broadly agreed in a meeting to something where they actually have to ratify it and sign it. So it takes a few years for that actually to happen. Now, the main objective of the Climate Convention is to achieve stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. So that's very relevant to our meeting on extremes, because a big concern about climate change is, of course, increasing frequency and intensity of extremes. It's not the only concern, of course, but it's one of the main concerns. So I've said it's in a framework agreement, and the first additional agreement that was linked to it was the Kyoto Protocol, which you've probably heard about. It was agreed in the town of Kyoto in Japan. You'll find that most of these agreements are named after the place where the negotiations took place. So that's why they have all these exotic names set to them. And that was COP3. So that was quite quickly after the convention was set up. And it set emission reduction targets for developed countries, on average about 5% reduction from a 1990 baseline up to about 2010. So not a huge reduction, but nevertheless, at the time seen as quite ambitious. Pushing forward, one of the things that came up in Kyoto was the use of land use change and forestry and reduction in deforestation as being part of what would be accounted as emission reductions. And the rules for that were quite complicated and had to be worked out. And the Marrakesh Accords, which was COP7, finally agreed the rules for the role of forests. We then had to go quite a long way forward to COP15 before we actually had the next main meeting, which was to expand what was agreed in Kyoto to a much more universal global goal. And that was actually recognized that we should aim to cap temperature rises to 1.5 to 2 degrees overall. But that didn't actually formally recognize that. It was COP16, in fact, where it was actually put into sort of decision text. But it was the Paris Agreement in COP21 2015 where there was a full agreement on universal action to reduce emissions, a global goal of 1.5 to 2 degrees, and a timetable for achieving that by the second half of the century. And also a whole lot of other important agreements which were relevant for meeting these global goals. Now, you might think, why all these negotiations? Well, it's strange, though, although there have been these punctuated mainstream agreements which have come out of the COP process. In fact, there's always something that needs to be agreed to push things further forward. So, in fact, you always have a meeting every year just to make things move forward. And that's mainly because each agreement always falls short to some degree of where you need to be. And although people are looking to Glasgow to achieve a lot, and I'll come to that at the end, I think it will only be another step along the way of what will become a very long road of agreements. Now, if we just focus on a particular year, the COP usually is at the end of the year, around November, December time. But before that, there's an awful lot of work goes into preparing for the COP. A lot of diplomacy, a lot of speaking to countries behind the scenes, lots of dialogues, trying to find out where people really would be prepared to move, what they'd be prepared to sign up to. And it feeding into that also quite important is the science of climate change. And of course, this year we had the sixth assessment report on the science of climate change from the IPCC. So that gives impetus for action on climate change. And if you're a negotiator, the thing you're looking for coming out of it is agreed text, something you can actually write down and everything that people have agreed to actually do. And that text then leads to government action and then wider societal action. In theory. And in fact, if you can imagine this is just part of an ongoing process, you come back in 2022, and you'll start the whole process again to pick up things that we don't get finalized in Glasgow and perhaps new things that also need to be dealt with. So it's a rather continuous process. Pre-COP is very important for building trust, getting consensus, and building in the science. And a whole lot of things are done through diplomatic activity, the use of other UN meetings, public dialogue, what the media has to say. So a lot feeds into the COP, as possibly you've been aware. And I would say that the COP is the main decision-making body of the convention, but it does actually have two technical bodies which deal with science and technology and technical aspects of implementation, the subsidiary body on science and technology and the subsidiary body on implementation. And just to confuse you even more, because this may come out, the Kyoto Protocol has its own committee or international body which meets at the same time as the COP, and so does the Paris Agreement, so that the Kyoto Protocol has got to the 16th year of its activity, and the Paris Agreement is just into its third. So you can imagine that in Glasgow, there's a huge amount of parallel activities going on and lots of agenda items in each. So people are very intensely engaged, and lots of people are doing different things, and somehow all has to come together at the end. And that often brings in the high level segment, and heads of state and ministers generally arrive usually towards the end of a COP. In fact, in Glasgow, heads of state are going to arrive at the beginning. So that's the first Monday and Tuesday. And I think what they will be doing is setting the scene and setting the tone. And obviously, the more heads of state that come, the more people have a hope that we'll make some really good progress. In fact, there will be another high-level segment a week later for those who've not sent heads of state, but have sent perhaps environment ministers or similar. Who goes to COPs? Well, each COP has a presidency, and this year the UK is the presidency, and it's jointly doing that with Italy, in fact. And there have been some meetings in Italy in the preparatory work coming up to Glasgow. Then each country sends its national representatives in delegations, and they're big politicians, negotiators, advisors, and support staff, maybe some 30, 40 people in some delegations, sometimes more. Smaller countries, probably quite a lot less. And there's 197 UN countries and one which is the Holy See, which is an observer state. The convention runs as a big secretariat, which makes everything work in between and during the meetings. And then also other organizations are very important in taking part, international governmental organizations, non-governmental organizations, and running in parallel to the actual negotiations, there's like an expo with lots of side events where people share views on climate change and show what work they're doing, etc. The media will be very much in evidence, and of course nothing like that runs without a whole lot of logistical support and hospitality, and the public will be able to come into part of the COP process in what's called the green zone, where they will see some of the expo activities. Now you might wonder, how does a COP work with 197 people? How can you possibly come to agreement? Well, although every country has the right to speak, in general, countries band together into groups of like-minded views, and they have spokes countries that speak on their behalf. And these are just some, I haven't got time really to go into the list, but G77 is one of the big groups, that's all the developing countries. The EU is clearly a group, and the umbrella group is the non-EU Western countries, more or less. Some have got very special interests like AOSIS, the Alliance of Small Island States, and they've got particular concerns about sea level rise, for example. So already you've moved down from 197 to about a dozen groups that actually can speak on behalf of the others. And that way you have got a way of managing a process which otherwise would be incredibly complex and difficult to manage. What does it look like? Well, the formal sessions are in big halls with all countries sitting behind their country flags, a bit of cardboard actually, not a flag. And it's a very well organized and very formal process. Countries, generally speaking, make statements, and what that main body does, it sets up working groups, which we call contract groups, to go and actually do the detailed business of negotiating. And here's a picture from a contact group, and sometimes they become more informal, and they're called informal consultations, and that's where people are actually arguing over text and arguing over what it is they're going to try and agree. And sometimes these go on well into the night. Not so much now because we've tried to avoid doing that, but it's not unknown for people to working through the night at the end of some of these contact groups. Of course, a COP is about meeting people and agreeing and sharing ideas and exchanging views. And it's not just in formal sessions or contact groups you're doing that. There's plenty of receptions, plenty of times to informally speak to people and actually find out what they really think and what's behind their thinking. And that's just as important in some ways as the formal negotiations. We've mentioned the high-level segment. Suddenly the whole tenor of the conference changes when ministers arrive. There's lots of people rushing around, lots of press, and there's a definite buzz about the place. I've presented this as what I call the COP pyramid, because basically what you see at the formal sessions is the top of the pyramid, and what actually happens below that are all these contact groups, informals, people meeting bilaterally, and importantly, the main groups that represent groups of countries have to coordinate their position as well. So you can imagine that there's a whole sequence of parallel meetings perhaps going on, all at different levels, different scales, but whatever they do, it all feeds back to the formal session to be agreed at the end of the day. And the output, well, I've already said it's a text. It might be a treaty. It might be what we call a COP decision. It might be just a conclusion from the subsidiary bodies. It might be a report of the meeting. But what comes out is written is the important thing from a negotiator's point of view. Lots of things get said, and they're not unimportant, but the things that actually are important for the future are what's written down and is as agreed by governments. Now, COP26. This I got from the presidency's website. And they've highlighted 4 different things that the COP is going to be working on. There's actually a lot more, but these are the sort of big ticket items. The first is to make sure that we try and meet a net zero emission for greenhouse gases by the middle of the century, to try and keep temperatures below 1.5 degrees, or at least to keep that possibility within reach. And as part of the process for doing that, countries have been asked, and many have already done so, to come up and volunteer what they will do to reduce emissions by 2030 as part of a step along the way to meeting the global goal by 2050. But unfortunately, quite a few major countries have still not said what they're going to do, and quite a few are, although they've made commitments, they're far below what really needs to be done to get to the 1.5 degree goal. And there's a talk in that in itself, so I won't go into the details of that. But that if we don't make good progress on this, that will be quite a bad sign and an indication that the job has got a long way to run. Some of the talks earlier on mentioned the importance of adaptation. So that is also an important part of the convention process, very much about supporting different countries in building up their infrastructure and being able to cope with climate change. And to do that, they need finance. So a big important part of the process is delivering an £100 billion per year finance for developing countries. And then finally, there's a lot of additional work on specific rules, which I can't go into at this point. And so that's a quick gallop through what the COP's about, and I hope it whets your appetite to follow up a bit more. Thank you, Liz.
Brilliant. Thank you, David. There are a couple of questions in the chat, but I might get you to just answer those in slower time. But quickly before I let you go, we're at COP, and I guess, what are your aspirations for COP26?
Well, I hope that there will be enough really positive commitments made that show that the world means business. It's important to remember that just making a commitment doesn't deliver. People still have to do things, but it's important to send a very positive signal to the wider society and the wider world, including the world of business, because at the end of the day, if we move to new technologies and so on, it's business that's going to produce these, and it's going to perhaps with government help initially, but at the end of the day, it's a whole societal transformation that's required. So there needs to be a strong signal that this needs to be followed, and people can do this themselves. They don't need to wait for agreements to do it, but if there is agreement, it really helps push things forward.
Great. Thank you for that. Really excellent. I think it helps to just demystify COP. We're hearing lots about it, and it's great to just understand the history, the context, and a little bit about COP26. So thank you very much, David.
Okay.
And as I say, if you're happy to answer a couple of questions that are in the chat on this, that would be really helpful. Okay, I can see Joe is here. Hopefully I can hear Joe as well.
Can you hear me okay?
I can hear you fine. Right, without further ado, I'm going to get your presentation up, and I'm going to hand over to you, Joe. So Joe is the National Flood Forecasting Duty Manager at the Environment AG, and over to you.
Thank you so much. I can't see any slides at the moment, but thank you so much for your patience as well. Hopefully going to go through these slides with you. I can't actually see any slides at the moment. Great. So my name is Jo Coles, and I'm at the Environment Agency, and I'm delighted to be here. Thank you so much for your patience. Apologies for the IT issues. I'm not sure what's going on. So as Liz said, I'm a National Flood Forecasting Duty Manager, and this talk I'm really going to go through that with you. And what we do to produce a national flood forecasting summary for daily briefings. So I thought I'd walk through that with you, and how we go about producing a flood forecasting, and then how we are adapting this in a changing climate. And we've heard from both Chris and Will on rainfall extremes, and so I think they were really good linking sessions. So yeah, it's great to be able to be here. So flood forecasting underpins our flood warning service that we provide to the public. The impacts of climate change and extreme weather means it's becoming more important than ever for people to be aware of what our warnings are and how the information we can provide can be used so that we can stay safe in a flood. So to start with, I will give you a background on what our role is at the Environment Agency. We were created 25 years ago to protect and improve the environment. We help people and wildlife adapt to climate change and reduce its impacts. We improve the quality of our water, land and air, by tackling pollution. But we can't do this alone. And we work as part of the DEFRA group with the rest of government, local councils, businesses, civil society groups, and local communities to create a better place for people and wildlife. So responding to the climate emergency is a core part of the Environment Agency's work, and we have just published our Living Better with the Changing Climate report, which you've probably all seen in the news. And this details the approach we need to take to adapt and prepare for significant climate impacts, especially for flood and coastal risks. So when it comes to incidents, we have a really important role. The Civil Contingencies Act of 2004 is the legal framework that sets out how we prepare for and protect the UK from hazards. And the Environment Agency is at the core of planning for and responding to and covering for many of emergencies in England. And so as a Category 1 responder, our role is to keep people safe and protect the environment from serious and lasting harm. And as part of this, we manage the warning, informing and advising the public. And I'll touch on how we do this during a flood event. The Environment Agency has an operational responsibility for managing the risk of flooding from main rivers, reservoirs, estuaries and the sea. And so I'll be focusing on river flood forecasting in this session. The most recent UK climate projections from the Met Office Hadley Centre Climate Programme confirm that we will experience wetter winters and drier summers, and with an increased likelihood of more intense rainfall leading to flooding. If we have a global temperature rise of between 2 degrees and perhaps 4 degrees, the predictions are actually quite stark. Winter rainfall could be up by 6% by the 2050s and up to between 8% and 13% by the 2080s. And then peak river flows could be up to 27% in the 2050s and 52% in the 2080s. The latest climate science suggests that the effects of climate change on daily extreme rainfall events are only just beginning to emerge, and extreme heavy rainfall events appear to be more intense and more frequent, but the record is as yet too short to be conclusive. But however, 6 out of the 10 wettest years for the UK in a series from 1862 have occurred since 1998. This year alone, and we've heard from in the talks previously, we've experienced a number of flood events in the UK and worldwide, and only this summer severe flooding devastated parts of Western Europe, Japan, and most recently in the USA and China. And as Chris mentioned earlier, we had storms Kira and Dennis in 2020. And I'll just touch on those. River levels from this event, Storm Kira, were either the highest or second highest recorded at a number of locations, such as on the rivers Ribble and Calder, and they're in the north of England. And then after storm, we had Storm Dennis arrived, bringing sustained and widespread rain to Wales and Western England, again causing severe flooding. And with further locations, including those on the River Wye, reaching their highest levels ever recorded. Approximately 2.4 million properties are at risk of flooding from rivers, the sea, or both in England and Wales, and almost half of these, almost 500,000 of these are at significant risk. The number of properties on the floodplain in England is expected to double by 2065. So the cost of incidents can be significant. The 2007 floods had an economic cost of £3.9 billion. And there is a 50% increase in mental ill health after flooding. So early warning of flooding enables people, businesses and organisations to take action to reduce the impacts and stay safe. Flood forecasting is an important part of this warning service, enabling us to assess the likelihood of an event, the scale of the flooding and where it may occur. We can also use this information to prepare for a flood event by operating assets including the Thames Barrier, other defences and pumps, mobilise the military and warn and inform communities in a timely fashion, reducing our exposure to extreme hazards. So our flood forecasting service is a partnership across a number of organisations, and apologies for this really complicated slide, but I thought it was really important to show how all lots of information and organisations work together. So to start with, on the left-hand side, the Met Office gather atmospheric data from radar and rain gauges to produce rainfall forecasts using their numerical weather prediction model. We use rainfall observations and forecasts combined with observed river levels from thousands of river gauges in our telemetry network across England as inputs into our computational models. The Environment Agency and the Met work in collaboration as part of the Flood Forecasting Centre to provide a 5-day national flood risk assessment. This provides a strategic summary for planning purposes, pulling in all the relevant information from across England. At a local scale, we run our river forecast models and provide detailed forecast information to our 14 area teams to issue flood warnings at a community level. And I'll now go into a bit more detail about those river forecast models. So in my department, in evidence and risk at the Environment Agency, we focus on forecast model development. And this diagram shows how we model the hydrological behaviours transforming rainfall and potential evaporation data into flow outputs. Catchments have different characteristics. Some are large, rural, groundwater fed, and therefore respond quite slowly to rainfall. Others are very small, urbanised, and respond very quickly to rainfall, such as those in London and in urban areas. It's really important that we understand the topography, geology, soil, urbanisation, and recent ground conditions, such as the soil moisture of each of these different types of catchments. Computational models use mathematical equations to represent these catchment conditions, and this allows them to model where the water will go and provide an output as a river flow or level. So the Environment Agency uses a variety of different models, ranging from the very simplest rainfall runoff models to the most sophisticated hydrodynamic models. The type of model we use depends on the different characteristics. So in upper catchments or smaller catchments, which are often called flashy catchments, river flows are highly dependent on the location and intensity of the rainfall. So generally, if you experience very heavy rain over these small catchments, it will just lead to flooding. Particularly of those particular characteristics, our flood forecasts are very dependent on the rainfall forecast. So there's little time for the models to run on the observed data, as the river levels respond almost immediately to the rainfall. So here we use rainfall runoff models, as they do exactly what they say on tin. They use rainfall inputs to provide forecast runoff as outputs. And with these models, we generally only have confidence in outputs up to about 6 hours ahead, as they're reliant on the rainfall data and quite simplistic in the way they model catchment characteristics. In middle and lower catchments, forecast flows are moved down the catchment via hydrological routing models. And then in more complex catchments, full hydrodynamic models are used. So extensive survey of the reach and floodplain is carried out and incorporated into the model. And the model also has the ability to deal with multi-directional flow, complicated structures, and floodplain dynamics. So a key component in determining if rainfall will run off into rivers or be soaked up are the ground conditions. Soils are generally more saturated in winter months, and therefore it will take less rainfall to result in flooding. However, even if the ground isn't saturated, extreme rainfall can cause flooding in those torrential downpours. So forecast models need to be highly sophisticated to cope with the complexity of flooding impacts. We need to understand in-bank and out-of-bank flow, the impact of flood defences on our flood flows, and what happens when defences overtop and when flood storage locations fill. So downstream conditions are also important, as in some locations, high tides or other larger river can act as blocks for floodwater exiting the catchment. So any real-time operational flood forecasting model is fully calibrated and tested before we use it. And we use historic data to run the models as if live for each flood events to ensure the model can replicate past flood events accurately. As part of the calibration stage, the model developer is also required to test if the model is unduly sensitive to rainfall and likely to cause false alarm, which can undermine future readiness to respond to flood warnings. And we continually recalibrate our models, part of our maintenance program within my team, and develop new models to improve our service. And of course, we've heard from both Will and Chris about kind of climate change projections. And we also factor in climate change, a percentage which varies across the country to account for these. And we also take into account error correction when running real time. So as a flood forecaster, we're continually monitoring rainfall observations and river flows through our extensive network of gauges. And these gauges transfer data typically once or twice a day, but in flood events much quicker, as much as every minute. On the previous slide, I explained how we model river outputs, but what does this actually mean? So you can see this hydrograph on the right-hand side, which is what a flood forecaster will interpret during a flood event. So the rainfall input is at the top, and you can see on the top left-hand side, that's observed rainfall, and then on the top right-hand side, that's the rainfall forecast that will be input into the models. And then below, you'll see we've got the hydrograph, the forecast model output. So on the bottom left is the observed river flow, and then on the bottom right is the forecast river flow, which is what the flood forecaster will interpret. We also use flood alarm levels to alert us when a river level is either forecast or is observed to rise in particular flood in particular areas. So how do we convert a level to a flood warning? Alarm levels are linked to our flood warning codes. We use survey data to set the threshold of the first property to flood, and this level is attached to the river gauge. So as the river level rises and passes through a threshold, we will receive an alarm. Alarms are all generated on our river forecast data. So to convert the river flows into a level, we use a rating curve, and an example of that is at the bottom of this slide. And if we receive an alarm, we will inform our flood warning duty officers of the flood forecast, who then issue flood warnings dependent on the expected water level. And our flood warning codes are used to alert people who are at risk, flood risk during a flood event. So what are our flood warning codes? And these actually, they obviously differ from the National Severe Weather Warning codes as well. And these are issued by us from the Environment Agency. So a flood alert is issued to a community if a flood is possible, and this is a first flood alert level. What we would want you to do is prepare and pack medicines and insurance documents and visit our flood warning service. The second alert is the flood warning, which is issued to the community if flooding is expected and immediate action is required. So moving things upstairs, turn off gas, water and electricity, move family and pets and cars to safety. And then the third and most severe flood warning is a severe flood warning. And this is issued when there is a danger to life, when there is significant disruption to the community, and we follow emergency services advice and call 999 and stay safe. So over 40 million early warning messages are sent for river and sea flooding over the past 10 years. And we have a well-established flood warning system that has 1.4 million registered cities which receive warnings via automated telephone calls, email and text. So as I said, we receive rainfall forecast information from the Met Office, and we can get signals of heavy rainfall up to 10 days in advance. And by feeding these into our models, we can use outputs for planning purposes. And then closer to the event, we issue flood warnings. We can be more confident of a flood forecast if we run the model on observed rainfall rather than forecast rain. But forecasting can still be very uncertain due to so many variables such as catchment conditions, location, intensity of rainfall. The Met Office uses ensembles to generate a range of scenarios. To deal with uncertainty, we use best estimate and reasonable worst case scenarios to help with our decision making, which test the impacts of the most likely rainfall, which is the best estimate, and the worst case rainfall, which could be very low probability but high impact if it does occur. And these are presented in the hydrographs at the top. So you can see two very faint lines, actually, apologies for that. We continue to develop more probabilistic outputs, such as the one in the bottom right, which show an envelope of river level outputs. The communication of this is something we continue to research, and how we can make this as clear and as simple as possible for decision making. So we use best estimate and reasonable worst case scenarios to give us a national summary of what type of flood event we may be looking at. The 5-day flood guidance statement, which is issued by the Flood Forecasting Centre, can likelihood of flooding from different sources. An example of this is at the top of the slide. In my own role as the National Flood Forecasting Duty Manager, we also produce a flood impacts timeline, which kind of brings in all the local information from scientists across England to provide a more local detail of our model outputs and a kind of timeline of what we think those impacts are going to be. And all this forecasting information can be used to help us prepare incident rooms, rosters, flood defences, maintenance of assets, etc. And then ultimately issue those really important flood warnings to the public. So longer term, seasonal forecasts are used within the Environment Agency to help us plan our rosters and maintenance schedules. And we feed a lot of this information into our .gov.uk website, such as river levels on the internet. In fact, some locations you can actually see some of our flood forecasts as well. We reach an estimated 1 in 10 of the country's population through digital platforms, and their data is downloaded around 200 million times a year. But a key action for us, for the agency, is to grow this significantly over the next 5 years. So, and hot off the press, actually, we've had a major refresh of our live flood forecasting and warning information based on the user experience, with more local knowledge at its heart. And this is actually called Check for Flooding service, and that is now live. And finally, it brings me to finish on the latest report, which we've recently published, Living Better with a Changing Climate, states that in the face of a changing climate, we need to also make our places more resilient to flooding and coastal change, so that when it does happen, it causes much less harm to people, does much less damage, and ensures life can get back to normal much quicker. So adaptation is just as vital as mitigation. And I think really flood forecasting and modelling play an important role in enabling us to plan and prepare for flood events and warn and inform people to stay safe. So it's thinking about how do we incorporate that into our models by stress testing them and making sure that they work in kind of more extreme events, increasing our and also better coverage across the country, bringing, so we can monitor and also forecast better. And we also need to continue to raise awareness so that people can make informed decisions to stay safe during a flood. And that's me. So thank you very much for listening. So sorry.
Brilliant. Thanks, Jo. I'm really pleased we managed to get everything sorted so that we could hear your presentation. No, absolutely. And these things happen, but no, we got there in the end. That's great. Got time for a few questions, actually. So there was one from Ian about, you mentioned quality of river water. So he was just asking what is the problem?
With regards to quality, do you mean actually the
I presume this is the impact of the quality on the river water because of flooding events.
Quality of our flood forecast or something like that. I think really when it comes to water quality, that's probably outside area. So I think from an Environment Agency perspective, one of our key things for us to do is maintain what we do is improve the quality of our water, land and air by tackling pollution. And I guess that is one of the biggest things that we do in our incident management, actually. So yeah, we often respond to environmental incidents as well as flooding incidents, and there's a whole range of incidents that we are responsible for managing as well. So yeah.
Great. Question from Andrew about who's in charge of making the decision around the Thames Barrier to close it. Is that something that the Environment Agency does, or is it responsibility of other organisations?
At the Thames Barrier, and they work 24/7 monitoring kind of the tidal impacts and so forth. So the decisions are through there, really. We've got a whole there's a big team that continually work from the Thames Barrier.
Great, and a quick question for me. There are other questions in the chat, and I'm hoping, Jo, you'll be able to kind of answer them in the chat. But Will showed a couple of pictures of the recent flooding in London. The very localised flash flooding events that aren't due to kind of river overflowing or flooding from rivers.
So
how do you get involved in producing warnings for those kind of flash flood
The Environment
events?
Agency aren't responsible for issuing flood warnings for those. The surface water is something that's managed by local authorities, but the Flood Forecasting Centre does provide that strategic overview and that forecast.
I think we've lost Joe. God bless. Okay, I'm going to move on. Joe, hopefully you can just kind of answer my question, I guess, and the other questions that are in the chat. Oh, you're back.
Yes, sorry. This is the issue with my connection. So we issue for Main River and Sea the flood warnings. But yeah, I'll put it on the chat.
Brilliant. Perfect. As I say, I'm so pleased that we managed to sort out technology so we could hear your presentation. So thank you very much for that.
Thank you.
So we're now going to move into the final session for this event, and we're now moving into the Weather Photographer of the Year. And I will be introducing my colleague from AccuWeather, who will be presenting the winners, or announcing the winners. But I've just got a few slides really to give you some context and background to the Weather Photographer of the Year competition and this particular competition this year. So this is the 6th year that we've been running this competition, and we opened the call for entries in the spring of 2021 and left that open for a few months, and we received a record-breaking number of entries. So nearly 9,000 entries were submitted by 3,300 photographers from I think there's about 114 different countries around the world. So real input, an international input into the competition, which we've seen in recent years. This year was a little bit different. We had a new category. So we had a category for mobile phone entries as well. And that was very popular. As you can see here, we had over 3,000 entries from 1,285 photographers for this mobile phone category. Number of judges were involved. So I was on the judging panel again this year, and joining me was Jess Farrell from AccuWeather, who is a senior weather editor. So he is a meteorologist working at AccuWeather. It was his 2nd year on the judging panel. He gets involved with not just operational meteorology, but he's a blogger and a photographer himself. And he oversees the AccuWeather weather news stories and social media channels. So that's Jess. We had a guest judge, so that's Jo Bradford, who she was judging the mobile phone category. So her background is in mobile phone photography. She's an award-winning photographer and a best-selling author of Smartphone Smart Photography. We're also joined by Aisling Creevy, who is a fellow of the Royal Meteorological Society. She's also a registered meteorologist, but she's a meteorologist that works at ITV. She's a weather presenter there, and she runs her own podcast, which is called For the Love of Weather. Also on the judging panel, we had Rudolf Sulgan, who was last year's winner, so the 2020 Weather Photographer of the Year. And you may remember that image looking across Brooklyn Bridge, iconic photograph in wintertime. He lives in New York City as a photographer and a visual artist living there. And his focus in photography is around editorial stories with an environmental and social focus. And that definitely came out in his winning image from last year. And the final person on the judging panel was Kevin Thomas. And Kevin is the weather editor, the photo editor, sorry, for the Royal Meteorological Society. He has worked as a meteorologist, a weather forecaster, and a presenter covering radio presentations for the counties of Devon and Cornwall in the UK. And he also has alongside this his own love of photography. So some experts on the panel, both from their photographic expertise, but also their meteorological expertise. I'm delighted to say we've got a number of shortlisted photographers joining us today on this call. So I'm delighted you've been able to join us for Weather Live and also for the announcement of the winners of this year's photographic competition. So I'm going to introduce you to Dan Dipodwin, who is Director of Forecast Operations at AccuWeather. So if I can invite Dan to the stage. Dan has been working at AccuWeather for a decade now. He joined them in 2011 as an operational meteorologist. Currently, as I say, he's Director of Forecast Operations, and this combines, I guess, his passion of meteorology with his passion of developing people within the organization. He's an active member of the American Meteorological Society, so I guess our sister organization over there in the US, and he serves on the board of private sector meteorologists. So Dan is here to announce the winners, and I'm going to hand you over to Dan as he takes you through the winning categories. Over to you, Dan.
Great. Thanks very much, Liz. Pleasure to be here again with AccuWeather and our partnership here with the Royal Meteorological Society in this really great event. And thanks to all the presenters, really interesting talks over the last several hours. So I have the fun job of announcing the winners of this really exciting photo contest. So first up is the Young Weather Photographer of the Year results. These are photographers aged between 13 and 17 years old. And we had a record number of entries this year with 366 photos from 148 talented young photographers. So the runner-up for Young Weather Photographer of the Year in 2021 is Finn Gardner, age 14 from Australia, with the image Thunderstorm versus Beauty. And there's Finn's image, really, really neat zoomed in image of a drop on a leaf here. He took this image in French's Forest, New South Wales, Australia, just after a thunderstorm. And for the runner-up, Finn's prize is a signed copy of the book Smartphones, Smart Photography by competition judge Joe Bradford. So congratulations to Finn. All right, so we'll move to the winner then of the Young Weather Photographer of the Year in 2021, and that is 17-year-old Phoenix Blue from Kansas with this photo of a Kansas storm in Goddard in the United States. Here is Phoenix's picture, which is just an awesome picture of a storm approaching parts of Kansas. She took this photo on an iPhone of the beautiful clouds coming in right before a storm. Judge Jesse Farrell said anyone who's experienced a severe thunderstorm knows about the eerie, deep green blue color that sometimes presents as the storm approaches, and this photo really captures that in a bottle. It's all the more impressive that it was the winner for the youth category. So congratulations to Phoenix on this awesome photo. And as a prize, Phoenix wins a $350 voucher for REI, Outdoor Gear and Apparel Company, and a copy of the brand new book, Weather, A Force of Nature, Spectacular Images from Weather Photographer of the Year, which has some of the most powerful and dramatic images of the past 5 years of this competition, published in partnership with the Natural History Museum. So now we'll switch categories, and we now have the mobile phone category, which was, as Liz mentioned, new this year. And the judges were so impressed by the quality of the photos received that they decided to select a top 10. So we'll do a brief slideshow. We'll go through the top 10 that they selected and enjoy, and just take a moment to enjoy these stunning finalists in the mobile phone category. I'll just pause on each one of these here for several seconds so people can enjoy them. These are really all amazing photos, and especially that they were done on mobile phones. It's amazing the cameras that we have these days on these devices. That's something I'd like to see someday in the U.S. Go storm chasing. I've yet to do that. You gotta know what you're doing though. And just a couple more here. It's a really cool sun halo. All right, so out of those 10 finalists, we do have a runner-up for the Weather Photographer of the Year 2021 in the mobile category. And the runner-up is Susan Kine Andrews from County Wicklow in Ireland with her photo Between Showers, which was taken on her iPhone on Greystones Beach with her cockapoo, Evie. Really awesome picture here of this double rainbow. There apparently was a third bow too, but it was invisible to the camera. She took a couple snaps on her phone to remember the stillness and the emptiness of this beach with only the elements and weather for company. Really, really peaceful and awesome shot here. As a prize, Susan wins 250 pounds cash and a signed copy of the book, Smartphone, Smart Photography. Congratulations to Susan. And we will then unveil the winner of the Weather Photographer of the Year 2021 mobile category. That winner is Christopher De Castro Comeso from Abu Dhabi, UAE, with Foggy Morning. This really, really neat shot. This image that Christopher took was of the Qasr Al Hassan, one of the oldest landmarks in Abu Dhabi, in December of 2020, when the temperature was dropping. He was on his way home from work, he said, after dropping his wife at work, and when he saw the fog forming, he immediately took out the only camera he had, which was his Huawei mobile phone, and captured this really awesome shot. Judge Joe Branford commented that this photo stood out for the ethereal quality of the light as it penetrates the mist and diffuses the beautiful desert colors, creating an almost otherworldly scene. The picture really sums up exactly why the smartphone has become such a popular camera. And it was Christopher's reach in the moment, and the mist appeared and allowed him to capture this really, really amazing scene. As winner of this category, Christopher receives 500 pounds in cash and a $350 voucher for REI, and also a signed copy of Smartphone Smart Photography. So congratulations to Christopher on this excellent photograph. And then finally, we have the main category of the Weather Photographer of the Year 2021 competition in association with AccuWeather. You'll have already seen the slideshow of our fantastic finalists, and now it falls to me to announce who was voted the public favorite when we put them to a vote towards the end of the summer. We had an overwhelming response to thanks to everyone who cast a vote. We had 12,392 votes cast for the 21 finalists that were from 15 different countries. And the winning image of the public favorite was lightning from an isolated storm over Cannes Bay, taken by Sergei Zaka from France. This is just a stunning picture with the lightning coming off the anvil on the left side of the frame and clear sky behind it. After driving 300 miles, waiting for 8 hours and a half night sleeping in the car, Sergei captured this photo of a thunderstorm on a full moon night over the famous Bay of Cannes in the south of France. That's a lot of dedication for this picture, driving over 300 miles and half night sleeping in the car. The judges commented that few storms are as beautiful as those isolated over water. The photographer was a perfect distance away from the storm to capture three things crucial for a winning photo composition: the sky, the storm, and the water. If you haven't seen a thunderstorm over water, I highly recommend it. I was able to see one this summer in the off the Jersey coast in New Jersey, over the Atlantic. So as a prize, Sergei wins a copy of Weather, A Force of Nature, spectacular images from Weather Photographer of the Year. Congratulations to Sergei on this amazing photograph. And it doesn't just end there, as the judges also agreed with the public, and Sergei also takes home the judges' second place runner-up for Weather Photographer of the Year. And congratulations to Sergei also on this excellent award. And as a prize for the second place runner-up, Sergei's also awarded 100 pounds cash and a copy of Weather, A Force of Nature, spectacular images from Weather Photographer of the Year. All right. Now we get to move to the first place runner-up for the Weather Photographer of the Year 2020. And it's from Evgeny Borisov from Russia with his photo of self-portrait in a boat. And here's this really, really fascinating picture. He took this self-portrait using a quadcopter at Lake Kokol in Russia. To Evgeny, the uniqueness of this photo lies in his experience with the weather behind the lens. It changed so significantly in the time that he was there. He felt the season shift, not just between days, but over just a couple of hours while he was there. In order to take this shot, he waited for the first snow to fall, which covered the ice on the lake in a white blanket, leaving these areas of open water, which you see as the darker colors here on the image. And there were vivid streaks in the white. Just a couple hours after this photo was taken, though, the whole lake was covered with white snow, and as winter was approaching. And as a prize, Evgeny wins 250 pounds cash and a copy of Weather, A Force of Nature, Spectacular Images from Weather Photographer of the Year. Congratulations to Evgeny on this excellent photograph. And now we come to the main announcement of this year's Weather Photographer of the Year 2021 title winner. And with his spectacular photo, Morning Fog, taken on an opaque autumn day from a small church on a hilltop in the town of Aruno, Italy, this year's winner of Weather Photographer of the Year 2021 is Giulio Montini from Italy with this stunning photograph. Judge Jesse Farrell said, fog conditions at sunrise can really create surreal landscapes with unique colors that can only be captured from high above. In this picture here, we see the sun's rays illuminating or illustrating the cotton candy nature of the fog. It's really quite the capture. And I know Liz has some more information on what drew the judges here to this photograph.
Yeah, absolutely. I think, when you scan through nearly 9,000 images, it's often the dramatic images that draw your eye first. But this one, I certainly sat on for a while. And, you can sit and look at this for hours on end, and every time you come back to this image, there's something new and different that you want to kind of take away from it. But it is so atmospheric, and it's peaceful, it's serene. There's definitely a kind of three-dimensional as you kind of disappear off back into the distance. But it's a beautiful image. It's certainly something that I would want to have kind of up on either my computer screen or on my wall at home, just to kind of take me away from the kind of stresses and strains, I guess, of the world, and just to kind of relax and enjoy, I guess, the beauty that we see in our atmosphere. So, and I think that came across to all of us, the whole judging panel. It was very much a unanimous decision that this spectacular yet serene image was, it was just beautiful and almost took our breath away.
Great. Thanks, Liz. And as a prize for his winning photograph, Giulio wins 500 pounds in cash and $350 voucher for REI and a copy of Weather, A Force of Nature, Spectacular Images from Weather Photographer of the Year, and as well as the very exciting and prestigious title of Weather Photographer of the Year 2021. So congratulations to Giulio and everyone who participated and had an award here in this contest.
Great, thanks, Dan, and a big congratulations from me as well. Some spectacular images, and very hard to shortlist and very hard to choose the overall winners, but congratulations from me. Thanks, Dan. Thanks to AccuWeather for their support and sponsorship of the competition again. We look forward to kind of working with you guys as we go into next year's competition. So as you can see, some exceptionally high quality images that have come through in this competition. If you're interested in seeing those images close up, can I encourage you to take a look at our calendar for next year, the 2022 calendar, where you'll see all of these images available as you flick through the months of the calendar. So something that you can enjoy and take pleasure with as we go through the months of next year. There's a discount code available to everybody who's attended today's event. So if you type in calendar 10, you can see that at the bottom left of this slide. When you go into the Society's shop, and again, the URL for our shop is shown at the top of this slide, you'll get a discount, a 10% discount on our calendar for next year. So I'd recommend you pre-book your calendar now, because they'll be disappearing fast. So thank you very much for that. And then also just to let you know, and this was mentioned as one of the prizes for a number of the categories, we're about to publish a book called Weather, A Force of Nature, and it pulls together all the images, or many of the images over the last 5 or 6 years of the competition. A beautiful, spectacular collection of images showing, I guess, the dramatic but also the serene nature of meteorology from around the world. And we're publishing this in partnership with the Natural History Museum in the UK. Again, if you're interested in finding out more, I'd point you to the Society's website, armets.org, where you can again pre-book your book, for this beautiful book. So thanks for that. So that leaves me just to give you a little update of what the Royal Met Society is doing at COP26 in Glasgow in a couple of weeks' time. When we send out an email thanking you for attending the event and asking you to complete a survey, we'll give you a link to register for updates on the COP26 bulletin. So we're doing 2 bulletins. One will be a daily bulletin issued at the end of each day, summarising what's happening at COP, taking you behind the scenes and meeting people in Glasgow to understand what it means for them as well. And the second one, which you may be interested in, is we're producing a daily bulletin for teachers and schools, and they'll be distributed out the evening before, but it'll look at the next day at COP. So the aim is to be shown at morning registration, and we'll take a look at maybe what's happening at COP on that day and get that discussion going within schools and within the classroom. So it just leaves me to say a huge thank you really to everyone who's been involved behind the scenes for putting on this event, but our speakers who've taken the time out of their busy schedules to join us today. I hope you'll agree there's been some excellent presentations, a really in-depth look at extreme weather events, both here in the UK, but from around the world as well. We've taken a look at how we provide warnings on those extreme weather events, both now and looking at how that's going to change in the future. And also a look at COP and COP26, as I say, will be headline news really for the next few weeks. So a big thank you from me. This is the second year that we've run Weather Live virtually, and as I've just mentioned, we'll be sending an email out asking you to complete a short survey. It's really important for us just to understand what you liked about Weather Live, what you'd like to see us doing differently next year, and whether you'd like to see us going back to a face-to-face event next year or whether we'd like to keep it as a virtual event. These are the kind of questions we'll ask in a survey. So we'll be interested to find out more about your own thoughts on that. So without further ado, I'm just going to close off. 4:05, we're on time. Thanks for bearing with us with all the technical issues we've had today, but hopefully you've enjoyed what's been a really interesting few hours, really just looking at extreme weather events. So without further ado, I'll just say bye from me and thank you for joining us.